Welcome to my complete beginner's course on user authentication in web apps. In this course, we're going to be talking about how do you actually write that register form or the login form for your users using Node.js, Express, and Passport.js. And then later in the course, we'll actually go into how do we apply these strategies to an Angular application, and then even further, how do we write our own custom JWT authentication option? But before we get into that, I want to just introduce myself. I'm Zach, and I'm a full stack developer. I've got a smaller YouTube channel where I cover a lot of these topics, and I've been writing code for about 4.5 years, pretty much every day at this point. And I'm super excited to share this particular series because it was one of the biggest struggles that I had when I was first learning to code. I struggled with it for two main reasons. Number one, I was scared of it. I was scared to write a user authentication option because, everyone talks about, InfoSec and trying to secure your web apps as strongly as possible and how there's always, loopholes and bugs and, exploits and stuff like that. And so this whole user authentication topic was very intimidating to me. The second reason that it was really tough for me is because everyone made it look so easy. I would watch tutorials where we'd get through the user authentication section in about 10 minutes, and I was left just scratching my head because I had no idea what had just happened. I had copied the code in the tutorial, but I had no idea what was going on behind the scenes. In this tutorial, I want to solve both of those problems. So with the security side of things, this all gets easier when you realize that when you're first building your apps, the prototype version, it's not important to, secure your app on a grand scale like a corporation would have to. The methods I'm going to teach within this course are perfect for someone who's just trying to get a basic auth strategy implemented and put it into their, prototype app or even a small scale business. It's going to be secure enough for something like that. And on the second point, in terms of understanding what's going on behind the scenes, I really hope that this tutorial is the most in-depth user authentication tutorial that you have ever seen. As you can see by the length of this video, it is very long. And the reason being is not because it takes us, this many hours to implement authentication, but because it takes us this many hours to understand all of the different components that go into an authentication scheme. For example, if we're using Passport.js, we have to understand middlewares in Express because Passport.js is a middleware, and not only that, but it's actually a little bit more complex middleware than you're probably using on a normal basis. On the actual authentication side of things, there's a ton of topics that we don't really, associate with user authentication when we're just trying to implement it. For example, do we understand cookies in the browser? Do we understand HTTP headers that allow us to set those cookies? Do you understand how a JSON web token works? What's in the payload of that JSON web token? And furthermore, in the payload of that JSON web token, we're using techniques like hashing algorithms and cryptography. These are not simple topics. There are universities that have entire curriculums on just cryptography and concepts associated with it. So as you can imagine, talking through all of these things is going to take some time. But I can assure you, I'm going to walk you from point A to point B, and I'm not going to leave you hanging on any part of this tutorial. I genuinely hope that you enjoy it as much as I enjoyed making it. And at this point, I think we're ready to jump in. Today, we're going to be talking about how you can implement user authentication in your web applications using Node.js, Express.js, and Passport.js. And we're first going to kind of jump into what are your authentication options in general. I know that's a question that I had for a long time. What do we have? I hear stuff about JWT, username and password, and then you've got all this other stuff like Auth and even some custom strategies that you can use to authenticate your users. So we'll go through that. Then we'll talk a little bit about the Passport.js framework, what it is, what kind of structure does it use to authenticate users into the apps, and then what are some of the different strategies that you can use within it. And then finally, we'll actually go into the implementation of the Passport local strategy and the Passport JWT strategy. Although we'll talk about which strategies we might use in different situations, both of these strategies are going to be really good for anyone who is just trying to get their app off the ground and their primary focus is not necessarily on authentication, but they actually need authentication to get it off the ground. So these are kind of like the bare bones, most basic way to authenticate users into an application, and is going to be great for individuals, small teams, startups, anyone that is building their application from scratch. There are a few prerequisites for this tutorial series. I've pretty much assumed that you already know the basics of coding within the Node.js ecosystem. So that means you have a pretty good understanding of Node.js modules and package.jsons, all of that kind of stuff, as well as things like the Express framework, also things like asynchronous programming, so promises and callbacks. Hopefully you're at least a little bit familiar with all of the topics here on the screen. If not, you can still get through the tutorial, but I would highly suggest kind of brushing up on anything that you don't have a very basic understanding of. The first thing that I want to cover is what are your authentication options here. Before we get into any coding, it's pretty important to take a look at what's available to us and deciding what is my use case and what's going to be best for that use case. So on the screen, I've laid out all of the authentication options that you might find if you are in the Node.js ecosystem or any other ecosystem for that matter. And they are listed from least complex to most complex. But that does not mean that the least complex option is the worst option. It just means that as you kind of move up that chain, it's going to require a little bit more understanding, more pieces that you have to understand to implement the strategy itself. In the scope of this tutorial series, we're just going to be sticking with the left two, so the session-based authentication, aka the Passport local strategy, and the JSON Web Token or JWT authentication, or aka the Passport JWT strategy. Now you also have a little bit more complex authentication that you'll see, especially if you're trying to use a large API like maybe the YouTube API or any Google API, even GitHub's API. These big companies rely on OAuth. It's just a protocol to give different access rights to users trying to access resources within their API. So you'll kind of get the gist of what that is as we get into the JWT authentication, but I'm going to stay away from completely diving into the OAuth. Although we're not going to actually get into the coding implementation of solutions like OAuth or even custom solutions, it's definitely important to at least touch on it. So what OAuth is all about, it's just a protocol, and I know that can get pretty confusing when you have software as a service providers such as Auth0 and Okta, among others, that actually provide this OAuth protocol as a service. So it's really confusing if you look at those companies, namely one that's named Auth0, which sounds like a protocol. It gets really jumbled in your head, like what's the protocol, what's the company, how is all of this working? So really what the OAuth protocol aims to do is separate out the two components of we'll call user authentication. I gotta be careful with the terminology here because there's a big difference between authorization and authentication. So on the left, with the JWTs and the local logins, the session-based authentication, that is all about knowing who the user is, and that is what we would call authentication. Now, on the other side of things, if you have seen things like social logins, like sign in with Google or sign in with Facebook, that's a little bit more about authorization. So that's kind of, it's not as much who we're talking about, but instead who has access to what resources. So in other words, you'll get into things like scopes. What does this particular subject or user have authorization to access? Does it have authorization to make just GET requests against the API, or does it also have authorization to edit certain resources within the API? So as you might guess, using the OAuth protocol, and you'll also hear things like OpenID Connect is closely related, that is going to be used with these bigger services where maybe one company, such as Google, allows users that have varying authorizations to access the API in the same way. So if I or you wanted to access resources from, say, Google's YouTube data API, so if we wanted to get YouTube analytics or something like that, we don't have authorization to do certain things within that API, and that is defined by the scopes that we are basically provided in our access token that's related to the OAuth protocol. Now, I know all of that sounds very complex, and it's definitely not something that you can even begin to understand completely in just a few minutes, but I did want to talk about that and kind of just mention what it is and why we're not going to get into all the details of it. I think we have plenty on our plate with the session-based authentication and the JWT-based authentication to even start talking about that. So those are your options. We're going to stick with the two on the left, the least complex ones, and probably the most common implementations that you'll see for startups and people who are just trying to get their application off the ground and worry about the complex authentication of it a little bit later down the road when they have either more resources, more money, or both that can actually spend the time to implement something a little bit more complex like the OAuth protocol. To wrap up this introductory video, I wanted to give a brief overview of what the Passport.js framework is. And the reason being is we're actually going to be implementing two different strategies within the Passport framework, but that just basically means that we have two different middlewares that are connecting into the bigger Passport.js middleware. So you might ask, what is a middleware? For those that are not familiar what middlewares are in Express or are just a little bit fuzzy on how they work, I have created a video that will be included in this playlist so that you can brush up on that and get yourself up to speed. But basically all that Passport.js is a middleware that integrates within your Express.js application and handles all of the authentication logic using the specific strategy that you choose to plug into the Passport.js framework. Now, the strategies that are included, if we go to Passport.js, we can go to the home page and see that there are plenty of different strategies here. So we can do anything from the Passport local and Passport JWT like we're doing, and we can also do something a lot more complex. You can see that we have stuff like the Passport OAuth 2, which is what we just talked about, or even something more specific, Passport Instagram. We can use the Instagram login to authenticate and delegate access to our users. So there's a lot of different strategies, and all of these strategies have been created by independent developers that basically say, okay, here's the Passport.js framework. It's just a middleware, and it allows me to kind of use that framework as a starting point, and then we can just build in the specific pieces of authentication in our own middleware, which we call a strategy. So in summary, Passport.js is just a framework that is a middleware that also allows individual developers to develop other middlewares called strategies that connect in with this bigger middleware that we call the Passport.js framework. And then all of that gets wrapped up into a bundle and put into your Express app, and it works seamlessly with your Express routes. We'll see in a lot more detail how each of these strategies, the local and JWT strategy, work as we go through the series, but it is important to just understand the basics of what this is. If I had to sum up the code logic of Passport.js in a few sentences, it would basically be this. So Passport.js is a middleware, as we just talked about, and on every HTTP request that a user calls to our Express server, the Passport framework is going to first pick up, okay, what strategy are we using here? And then it will use that strategy to say, hey, is that user that just requested that resource authenticated? If that user is authenticated, then Passport is going to let that user access the resource. It's going to, go into the Express route. If that user is not authenticated based on the strategy we're using, then Passport's going to return a 401 HTTP status, which is basically the unauthorized status. So that's kind of Passport.js in a nutshell. Again, it's going to get a lot easier as we see the actual code flow of what's going on with this middleware. Congratulations, you made it through the first part of this super long tutorial on user authentication. Now, we talked about all the different options here, and we're not going to be covering some of those delegated authentication options, but there's plenty to cover with the other ones. And particularly with the Passport local authentication strategy, where we're going to be using the Express session middleware, having a solid understanding of HTTP headers and HTTP cookies is going to be absolutely essential. As a web developer, you go on a bunch of different sites and you click that accept button when they say, we use cookies on this website, but do you actually know what that means? I think you're going to find this section interesting, but let's go ahead and dive in. What is an HTTP header? I think it's something that we know in the back of our heads kind of what it is, especially if we program a lot of web apps, but it's also something that we don't spend a lot of time trying to learn, and we frankly don't need to learn a whole lot about them. That said, we do need to specifically learn about an HTTP header called the set cookie and the cookie header in order to understand how server-side sessions work and kind of interact with the browser. So if we come to google.com right here, I always use this as an example just because it's a pretty arbitrary spot. If you open up your developer console here in Google Chrome and go to the network tab, you'll see that it is pretty much empty right now. But if we click refresh on the Google search, and we're basically doing a GET request to google.com, and you'll see a bunch of stuff loading. A lot of these are the resources that run the page or scripts. But at the top, you see this www.google.com. If we click on this, you'll see that there are some headers here. And you'll see that the headers come in three basic categories. First, you have the general headers, then you have the response headers, and finally the request headers. What we're specifically interested in this case, to understand what a cookie is and how it works, is the request and the response headers. But we can also kind of explore the rest. You can go on to MDN is a great place to look, and you can see there's a link to all sorts of different headers. So we can go down here into security, and these are all the different security headers that you could set in either the general, response, or request headers. Now let's take a step back and really think about what just happened when we pressed the refresh button in our browser to load google.com. If you think about it, a HTTP client could be anything from an IoT device someone like me sitting at my desk or at a coffee shop. You could think of it as just a laptop or a phone. Pretty much anything that connects to the internet is considered an HTTP client. Now, on the other side of things is all of the HTTP servers. And those servers, Google in this case, is going to house the information that the clients want to access or update or do other operations on. So in our case, what we did was do a GET request to google.com. In other words, we want the resources at that web page. So if you look at the headers here in the Chrome tools, you'll see, as we talked about, we have these 3 categories. So let's just go ahead and walk through each of them and see what was relevant to our request. So in the first one, the general headers, these can be either request or response related. They're just kind of general metadata about the request, such as what is the URL that we're requesting, what type of method are we using. So this is a GET request. Those are in the request side of things. Now if we go to the response side of things, you'll see that we got a status code of 200, which means that we requested data from Google and it sent back the data successfully. So you can see that we have several, things that kind of mix between the request and response. Now in our particular situation, when we searched Google, we didn't form, but the browser that we were using created a request header, which is basically instructions for the server in what data the request wants. So I'm the client here sitting at my computer. So the browser on my behalf is going to say, hey, whoever I'm trying to get these resources from, I'm going to put in the request headers what kind of data I accept. So you can see that we have things like the accept encoding, accept language, and then just the accept HTTP header. And we're basically saying that we accept HTML, we accept XML, and a couple other different options. But you can just think of this request header as the instructions for the server that you're requesting resources from or trying to modify. What type of data that the client, myself, will accept in the browser is not the only thing that you can put in this request header. You can put all sorts of other things. You see there's a cookie in here. We'll talk about that in a few minutes. But you also have things like the user agent tells us what browser is requesting this data. And then you can go to the MDN site and look at a broad variety of different things that you could put in the request header. So you can click on the request context and you can kind of see some of the things that you can put in that. So we know that HTTP headers are basically metadata about our HTTP request. So we can also do that on the response, which would be set by the server, which in this case is Google. So one of Google's servers, whichever gave us the content that we're viewing on the web right now, is going to set these response headers. And these response headers are going to give additional instructions to the client that requested the data in the first place. So you can go through a couple of these and see, you can see the content type. So if you remember in the request header, the client, which is the browser I'm sitting in and using right now, said I only accept a certain type of data. And then the response is going to say, okay, you only accept that type of data, here's the data, and here is what type it is. So this is useful if we're trying to figure out how to display that data in the browser. Of course, there are other things that you'll see here, but I want to direct your attention to something very relevant to what we're talking about right now, which is the set cookie header. Now you can see that the set cookie header is basically giving key value pairs. And you can see, right here it says expires equals Friday the 31st of January 2020 at this specific time. So you might be asking, well, there's a cookie header in the request object and there was a cookie header in the response object. How can that be? what is the difference between the two and how do they work. Over the next few minutes, I'm going to walk you through exactly how the set cookie and the cookie headers kind of work together. And then in another video, we'll actually talk about how this all plays into what we call a server-side session. The easiest way to understand what a cookie is and how it works is to remember that HTTP protocol is a stateless protocol. In other words, it's going to constantly forget what the user has done on the site unless we have a way to remember that. So in other words, if we go to Google, let's just imagine this scenario. We go to Google and we sign in to Google. And we'll just assume they actually probably don't use this method, but we'll just assume that they're using cookies and server-side sessions to authenticate us. So what happens is Google, the server, is going to say, okay, the client that just signed in gave us valid credentials, and so what we want to do is send something back that allows the browser to remember that this user has logged in. If we don't have anything like cookies or local storage, probably a more modern way to do it, if we don't have these types of persistent storage, then every time we refresh the page, the state that we had previously where Google said, okay, we logged you in, is going to have to be redone. So every time you refresh the page, you're going to have to enter your login credentials, which of course is a terrible user experience, and any site that does that is going to lose their users immediately because they're going to get completely tired of typing in their login credentials. So this is where the set cookie and cookie headers come in. So let's do a little experiment here, and I know this is not a perfect example, but I think it will do for what we're trying to accomplish here. So let's click on the application and open up cookies for Google. You'll see that there's all sorts of cookies. Google knows everything about everyone, so we can just go ahead and delete these. It doesn't hurt anything to delete all of these cookies. So at the moment, our browser has no cookies set whatsoever. So we can come back to the network tab, and let's go ahead and refresh the page once more. You'll see that we had this google.com here, and we can open up the response and request headers. And you'll see that in the request headers, it's pretty much the same as what we had looked at before. And then in the response headers, we once again have these set cookie headers. And what these are doing is basically saying, okay, or the Google server is saying, okay, client, I want to set this information about you. So we'll just assume maybe we just logged in and Google wants to tell the browser that I, the client, is logged in and we don't need to re-authenticate every single time that we refresh the page. So what happens here is we have these set cookie headers, and let's just pick a very specific key value pair here just to see what's actually happening. So let's get a pretty easy one. We'll just say the 1P jar. It gives us a date of 2020-11-21. I'm not exactly sure what that means, but keep this in mind. This is what we're going to be looking for. So if you go to the application, you'll see that now these are set in the cookies field. So we have the 1P jar and then the value that was set in this response header. So now what our browser will do is it says, okay, now we have a cookie set, so every request that we make within this domain, so google.com, I want to attach those cookies that were set based on this set cookie HTTP header in the response header. So what's going to happen is when we press refresh again, it's going to actually put these cookies in the request headers. So right here in this cookie request header, we should see something like these set cookies that Google, the server, had put into our browser. So let's click refresh once more. go to the google.com and look at the request headers, and you can see that now this cookie header right here has that 1p underscore jar cookie key value pair. So just to recap what just happened, we had a client, me, refreshing or doing a GET request against google.com, and whatever Google server that gave me that data said, I want to set a cookie in this client's browser. So it uses the response header to do that. It assigns these values in the set cookie header. And then when we reload the page, our Google Chrome browser, or any browser for that matter, is going to say, okay, my default behavior is to look up what cookies are currently set in my browser, and I'm going to attach those cookies to every single request for the domain context that it is applicable to, which is google.com in this matter. If you really think about it, this method of setting and then the browser just attaching the cookie to each request is a really powerful thing when it comes to user authentication. You could say, hey, maybe my server can do some sort of logic and say, okay, is that user valid, invalid, did they give me the right password? If they authenticated correctly, then I do the set cookie header in the response object, and then now the user or the client that is using my web application now has that cookie that says, yes, this user has already been authenticated, and then the browser, every time it reloads, will attach that cookie, and you don't have to re-log in that user. Now the real question is, how long do we keep that user logged in? And that's a totally arbitrary question, but we can do that with the expires piece of this set cookie HTTP header. If we come over to the network tab and look at the response headers from Google, you'll see that there's the cookie that's being set, so 1p jar. It looks like this is actually set on every GET request to Google, but you'll notice that it has an expires piece to it. So this is what tells the browser how long to store that cookie key value pair within the client. So we can actually go through this exercise on our own using some simple JavaScript to see exactly how it's working. So let's go to the console and type in a few quick commands. So first, we're going to create a new date, which is going to represent the date and time right when I click enter. So we'll say enter, and then we're going to say we want to set the time 20 seconds later. So let's do that. And then finally, let's set a cookie to the browser with an expires header at that time. So we really only have a few seconds, but you can see that we have a custom cookie that's going to be there for about 20 seconds. So if we reload right now, it shows that it's gone. So let's go ahead and do that one more time, a little bit quicker this time. So here's our cookie. Go over to application. You'll see that we have the custom cookie, and every time we refresh the browser, you're going to see that cookie is going to stay there. But then in about 20 seconds, which is coming up here in a few seconds, I think, you'll see that that cookie actually will drop off, and it will no longer be attached to the HTTP request. So if we refresh, you'll see it's gone, and that user will say that that was a cookie that gave a user or the client's authentication status. That's gone. The user has to re-log in. Now obviously you're not going to set a cookie to last for 20 seconds. You might more realistically say that you want the cookie to last for 2 weeks. And that is a really powerful way to keep some sort of persistent state within the browser and not require users to log in every time they refresh the page. The next part of this tutorial is all about Express middleware. In order for us to implement the Passport local strategy, which utilizes Express session, we're going to have to understand middleware. And that's because both Passport.js and Express session are both middlewares. If you don't understand this concept really well, then both of those libraries are going to be confusing to you. Furthermore, I'd consider this one of the most essential topics of programming in the Express framework. While the official Express documentation does cover Express middlewares in some capacity, and it's relatively clear, when I was a beginner, I'd never understood it fully. And even to the point, 2 years into my programming journey, I still did not have a solid grasp on this Express middleware. After learning it in depth for the first time, I can really confidently say that this is going to be one of the most important lessons that you learn, as a Node.js developer using that Express framework. So without further ado, let's dive into this Express middleware overview. When you start out using Express.js as a framework, it's an entirely middleware-based framework, but generally when you first learn it, you're just copying in, the different pieces, and that there's kind of something working behind the scenes, but you don't know exactly how it's working. So in this video, we're going to talk about how exactly does this middleware work, and how does the request, response, and next or callback object, as well as even the error object, work in an Express application. In order to do this, we need to spin up a really quick basic application. What I'm working in here, again, this is part of the Passport.js series, so I'm in the repository that we're using for that, but don't worry, this is just a basic Express app. So we first need to require in Express. I've already installed this with npm, so I don't need to do that. And then we say app equals Express, and then we just say app.listen on port 3000. So right there is the most basic form of an Express server that you can spin up. And if we were to visit localhost 3000, we're not going to get anything. But if we just throw in one simple route, app.get, and then we pass in the request, response, and next objects, and then we send some sort of data, we can now run this in the browser. So let's use nodemon, which is going to automatically update on every time I save, and we'll run app.js. So we're running app.js, it's listening on port 3000, and it'll be listening on localhost. So if we go to the browser and visit localhost 3000, port 3000, you should see the hello world. So we have a basic server running, and that's all we need to do to start understanding how middleware works in Express. So we come back to the code here, and the first thing that you need to understand is this right here. So with our app.get, this is just a route that we've established in our Express application. We are passing in a route string and a callback function. Usually you'll see it in this syntax, but to better understand it, we can just basically write a function where we say request, response, and next. Now, to make this even more transparent, what I'm going to do is name these custom properties. So normally you're going to just see it REQ, RES for request and response, and then next. But you don't need to call them that. It's just always going to be passed in. You can call them whatever you want. So we can say request object, response object, and callback function. So, well, actually, we probably shouldn't call it the callback function. We should say maybe next middleware or something like that, because the purpose of this last parameter is if we call it as a function, it will pass it to the next middleware in the chain. So we'll understand that a little bit better in a second, but first let's go ahead and write our function. So we need to give it a function name, so we'll just say standard express callback, and we pass in these three parameters, and then we can say res.send and hello world. So basically we've got the same exact thing that we had below in the app.get route. To implement this, let's just delete what we wrote here, and let's just pass in our standard express callback. So we've defined it up here. We know that express as a framework is going to pass in these three parameters, and so there we can just throw it into our route and click save. And then if we come to the browser again, if we refresh the page, it's going to say res is not defined, and the reason being is because I was dumb and forgot to update that. So now that we're passing in request and response object, we obviously need to also use that in the body of the function. So that was just a silly mistake, but now if we come to the browser and do it again, we should get hello world as we expected. So that's the most basic way that an express route works, and we're using this function that we had defined. So just like we could define this function, we can also define other functions which we call middleware. So the way that we do that is pretty simple. We'll just say middleware 1, and what we need to do is pass in those same three objects that we were using before, so the request object, response object, and next middleware, or whatever you want to call them. In this case, I'll just say REQ, RES, and next, like you would normally see it. And then we can do whatever we want in this middleware. So maybe we'll just say console.log I am a middleware. And then in this one, this is the standard express callback. This is where we return some data. We can say console.log I am the standard express function. So if we just define that function up here and we don't do anything with it, it's not going to do anything, obviously. But we can pass that into our route to make it work for us. So let's pass in the middleware 1 and a comma. So you can see that Express as a framework allows you to pass in pretty much as many parameters to the different route functions as you want. Let's go ahead and save this real quick. Let me open up the terminal a little bit more so that we can see what's going on. And let's go to the browser and visit that same route. We'll go ahead and click refresh here, and you're going to see that this is going to just keep loading. It's not going to ever return us data. And if we were to, copy this into a new tab and click enter, it's not going to actually return us anything. And that brings up a very good point with Express middleware. If we come back to our code that we wrote, you'll notice that in this middleware that we passed into our route that we were visiting, we haven't actually called this next parameter. So in the Express framework, the next parameter is going to be actually a function, and all we have to do is call it at the bottom of our middleware. And what that's going to do is it's going to say, for this route right here, we first run middleware number 1, or middleware 1, and in middleware 1 we call the next function that was passed in as a parameter by default by Express. And when we call that, it's going to basically say, okay, now we get to go to the next middleware, or in this case it's the last one, it's the standard Express callback. So if we don't put that next function and call it, it's never going to get to this last function, and we're not going to ever return any data. So now that we've called this next function, we should be able to go back to the browser and see a response. So if we refresh, we'll see that it should return hello world, and you see that it did return it. And if we come back to our code again, you'll see in the console that we printed, I actually ran this route twice, so we printed I am a middleware and then I am the standard Express function. And the order of this is very important because first in the route we run this middleware, and then we run the standard express callback. So first we're going to console log I am a middleware, second we're going to console log I am an express function. So that is the basics of how this middleware works, but we also have a few other things to understand. So what we've been using so far by passing the middleware into the route itself is a route-specific middleware. Now this is kind of, I just think of it this way, I don't know if it's the exact term that you would use, but I call this a route-specific middleware, but you also can have global middleware. So if I took this out of the route and I came up to the top right under the definition for the app and I say app.use, what this function built into Express expects is a function or a middleware that it can execute. So in this case, I'm going to just take middleware number 1 or middleware 1 and say app.use middleware 1. So what's going to happen is the Express app is going to initialize, and then it's going to initialize the middleware 1. So let's go ahead and see what happens in the console when we do this. So let me make sure I got this right. So we've got our middleware defined here, we call next, and we're initializing it with the app.use up here. So let's save that, and you'll see that nothing has happened in the console yet. You might expect, since we did this outside of a route, that it would just automatically print I am a middleware and go to the next something. But that's not the case. When we say app.use, it's basically just adding a piece to that chain of functions or middlewares that we're going to be calling. So once again, we have to come back to Google Chrome and execute this get route. So let's enter, and so it loads correctly, and then if we come back to the code again, now you're going to see I am a middleware and I am the standard express function. So what just happened here? Well, first off, we defined that this is the first middleware that we want to use in all of our routes. It's not just specific to this particular route, it's going to happen in any route that we define within our application. Next, we have the standard express callback, which is in this specific route. So first, the route's going to call middleware 1, then it's going to call whatever we had defined as the callback to that route. So the order of the middleware that we define and the scope, whether it's a global or a route-specific middleware, really matters. So let's go ahead and see what happens if we switch up the order of the middleware and maybe even add another middleware into this equation. So let's say we have another middleware called middleware 2, and again we pass in the default objects that we are provided by or provided with by the Express framework, and we'll say console.log I am middleware number 2, and maybe we should just update this one up here to number 1. So we've got middleware number 1 and middleware number 2, and what I'm going to do is say app.use middleware 2. Okay, so we are using two middlewares, and then we have the standard express callback, which at this point I'm just going to go ahead and put it in a form that we're used to seeing. So we'll just use request, res, and next. This is what you'll see in most tutorials, so I want to keep it consistent. So let's copy that in there, delete the function declaration, and then of course, since we changed the name of the parameter, we need to also change the name of the object that we're using to send the data. Alright, so let's just quickly recap what we got. We have one route in our application which has a very standard syntax. All we're doing is we're sending back an h1 tag with hello world in it. So far in this route, we haven't defined any route-specific middleware, but we have defined global middleware. So let's see what happens. Go ahead and kind of make your guess as to what's going to happen here. But if I had to guess, we're probably going to print I am middleware number 1 and then I am middleware number 2 when we call that route. And then finally, we'll console.log I am the standard express function. All right, so we've saved it. Let's go back to the browser, click refresh, and I don't know why it hangs sometimes here. Try it again. Maybe we have some sort of error. Did a little bit of refactoring. Nope, it was doing just fine. We've got all the things that we expected. So if you could guess, what's actually happening here is, again, we forgot to call the next function in the middleware too, so it never reached this final function. Save it once more, come to the browser once more and refresh. We should get a good response. Come back to the code and you'll see I am middleware number 1, I am middleware number 2, and I am the standard express function. Alright, so everything is as expected. And now is where the real understanding comes into play, because oftentimes when we're using an express application, we've got all sorts of middleware working together. In most express applications, you're going to have several app.use statements. So you might say app.use cores, cross-origin resource sharing, that's a pretty common one, or app.use body parser, and then whatever the configuration for that was. So you might have up to like 10, 15, even 20 different middlewares that you are adding to your express application. And so it's really important to understand that the order that we put these in matters. So if we were to put middleware 1 after middleware 2, all we did was change the order of those statements. If we save and then go to the browser and call that route, you're going to notice that when we come back to the code, we now have things out of order. So we have I am middleware number 2 coming before number 1. So that's really important to understand. And then of course, if you put one of these within the route itself, it affects the order as well. So let's add one more middleware to this equation. And let's just copy this, do the same thing. So we'll call this one number 3. Number 3 right there. And then we're going to take middleware number 3 and put it in the route itself. So let's copy it right there, give it a comma. And now what's going to happen is we should have middleware 2 called first, then middleware 1, then it goes into the route specific middleware. So then we have middleware 3, and then finally this last function, which we technically could call middleware as well. So let's see if that worked. We should have middleware 2, 1, then 3. So let's go to the browser, run the route, come back to our code, and you see that we have 2, 1, and 3, exactly how we defined it, 2, 1, and then the route specific middleware. There are 2 more things that I want to talk about when covering the topic of express middleware. And one of those is error handling, because an error handler in Express is also just another middleware, but it's actually a special type of middleware. So in order to define an error handling middleware, what we have to do is define a function with a 4th parameter. So let's go ahead and define a function called error handler. And you'll see that in this app I've kind of simplified it a little bit, so we only have one middleware. We got rid of all the rest of this stuff. But this time we're going to pass in an error parameter, then the request, res, and next parameters. So this is how we define an error handling function, and we can, this is basically a middleware, so we can do as many error handlers as we want. So if we wanted to catch specific types of errors, so we say if error.status equals something, then we want to handle it in this one, and then we could come down and do another error handler and say this is error handler number 2, and if error.status is number 2 or number 1, you kind of get the point. We can define as many of these as we want and handle different types of errors depending on the application that we're doing. But what is going to happen here is this error parameter will be populated with an error if it exists. So what we can do is we can say something like maybe instead of throwing the error explicitly, we'll say if there's an error, what we can do is res.send, and we can say there was an error, please try again. So something more friendly than a default error that you might get in the browser that would crash the entire application. So let's go ahead and comment this out for 1 second and see what happens if we don't have an error handler. So right now we don't have an error handler, and maybe in this middleware up here, instead of console logging I am a middleware and continuing to the next, we can say that we have an error object, which is a new Node.js error, so I am an error. And what we can do with this is we can pass it in the next function. So normally we just call next and it goes to the next middleware. This case, we're going to actually pass the error object. So this would be common, this would be more common in a scenario where maybe our middleware was doing something complex. We were making a database call and we were just catching any errors that happened with the database, something that we cannot control. So we always want to catch these errors, and if we do catch them, we want to pass them in the next function. So when we do that, we're going to go back to the browser real quick, and if we refresh this, it's going to say I am an error, and you're going to get the entire stack trace, which you don't want because this is where the users will see what's going on, and you obviously don't want to send this type of error to a user. You want to handle it in a more graceful way, and not to mention, if we do it like this, you can see down in the console or in the terminal that we've crashed our application. So if this is running out on a server somewhere and we don't know that this has happened, our application could be down for hours without us even knowing. So it's really, really important that we use an error handler in our Express application to catch these errors and handle them gracefully without crashing the Express application. So again, error handler, just another middleware with one extra parameter. So let's uncomment this error handler function. And normally you'd set this up a little bit more complex than what I've done, but we'll just go with this for now just to demonstrate the point. So we've got the error handler, and so now we're going to say app.use error handler. Now we'll go to the browser again, we'll refresh, and now we're getting a more friendly error message. Now that we've defined this error handler, let's go ahead and put it in as a middleware. So let's just say app.use error handler and click save. Now let's come back to the browser real quick and refresh. You're going to see this dreaded error message in the browser. And you're going to ask yourself why. We defined our error handling middleware, so we should have a friendly message here. Well, what's happening is we have done this out of order. And like I said earlier in this video, the order that you put Express middleware in matters. And in this case, we need to throw our error handler at the very end of our app. So after all of our routes and all of our middleware, we need to put our error handler. And the reason being is because if there is an error in any of our middlewares or our routes, which are basically just middlewares, then the error is going to be passed directly to the final error handler. So in this case, we have the error happening up in our first middleware. So what's going to happen when we say next and then error, Express is going to pick up on this and say, oh, there's an error. Let's send it past, let's skip the route here. We don't need to go into this. We need to just go straight to the error handler and handle it appropriately. So this is kind of how Express middleware works, and you can see that this will more gracefully handle the error if we come back to the browser and refresh. Now we're getting a much more user-friendly message. In many cases, you might do something instead of actually sending data like this, we could just say res.json, and then we could say error, and then our front end application could handle this error on the front end rather than, the server handling it. Alright, so we have covered how to handle errors using error handling middleware. And finally, the last thing that I think is important to cover when it comes to Express middleware is the fact that we can actually mutate or kind of append different properties and objects and functions to these parameters that we're passing through each of the middlewares. So what we could do here is let's get rid of the error in this middleware. Let's also get rid of the console.log. We just want to have a basic middleware. Let's call this number 1 again. Then let's say number 2. And let's put these in as global middlewares. So here's middleware 1 and 2. So first our route's going to call middleware 1, then 2, and then the actual callback for the route. So to demonstrate this, let's go ahead, come up to middleware 1 and say something like request.customProperty equals 100. Alright, so we just created a variable that is attached to the request object. Now since Express as a framework passes this request and response object through each of the middlewares, it will actually be available to us in later middlewares. So what we can do is we can say we define it up in middleware 1, then in middleware 2 we say console.log the custom property value is, and then let's put in that custom property. So in middleware number 2, we should print the custom property value is 100, but then we want to reassign it. So let's say custom property equals 600, just a random number. And then finally, down in our routes, we'll say the value is, and then we'll put in request.customProperty. And in this case, it's probably going to print, or not probably, it will print 600 because we have modified the property in middleware number 2. So let's save that, go to the browser, and see what we get. So we see that the value is 600, and that is because we set it in our second middleware, which was the last middleware that modified that property. Now, you might be asking, what is the point of this? Why did you show me that? Well, the reason being is because it helps you to understand how a lot of the middlewares that we use on a daily basis in Express are actually working. So if you're following along this series, the Passport.js series for user authentication, this is exactly how Passport.js, which is an Express middleware, is going to keep track of users whether they're authenticated or not. The Passport middleware is going to take that request object and it's going to actually append different properties to it. And also, if you watched the previous video in this series on the Express Sessions middleware, you also know that the request.session object is where the session is stored. So you can see how powerful this is and how we can actually store data within the request object, and each of our middlewares can have access to that data even if they come way after the middleware that first modified the data. So that's just kind of a brief explainer of how middleware works in Express and how error handling middleware works in Express. Hopefully it kind of broadens your Express horizons a little bit. I know when I first learned it, it did, and it made me a lot better Express developer. I now write middleware for all of my applications to do just ad hoc things, anywhere from authentication guards, so maybe we're checking a value of a user that we've received, maybe we're checking if they have administrative rights, and we use a middleware to do that. So the middleware would basically look up the user in the database, check the admin property. If the admin property is true, then we pass it to the next middleware. If it's false, then we might return something like 401 or 403 unauthorized HTTP statuses. All right, after this last section on Express middleware, we are now set up to really understand the Express session library. When you're implementing the Passport local strategy, it uses Express session under the hood, which can be extremely confusing. And when you read through the Passport documentation, it doesn't make it abundantly clear that this is happening. In this section, I'm going to teach you exactly how this Express session middleware is working behind the scenes, kind of independent of the Passport.js middleware itself. And then we're going to talk a little bit more about how that Express session is being looped into our Passport authentication middleware. Now, the really cool thing about this section is that learning the Express session middleware is not only going to help you implement a Passport local strategy, but it can also be really useful for other purposes within your web app. Well, state management is often handled on the front end with frameworks like Angular, Vue.js, or React. There is the possibility of handling some sort of state or application state on the back end in the form of a session. That is what the Express session library aims to do. But enough talk, let's dive in and understand all about this library. So in this case, we're going to be looking at a very simple Express app, and I'm going to take you through how the session is working, how the cookies kind of work with the session, and some of the configuration that you have to do to set up the Express session middleware. What I've got open right now is the repository that goes along with this Passport.js tutorial series, and we just have a folder for little one-off tutorials like this one. I've already created an application, which is an Express application, and I'm just going to quickly walk you through what I've done, and then we'll go through what's actually happening, what are some of these configuration options. So the first thing that I've done, I've already installed my dependencies. We've got Express, Mongoose for the database, and then Express Session, which is an NPM module. We then have something called Connect Mongo, which we'll get to in a few minutes. It's what we're going to actually use for the session store. Then, of course, we set up our Express app, pretty familiar to most people. We connect to our database right here. So I'm just using a completely unauthenticated localhost database. I've got that running in the background already. So if you're trying to follow along, be sure that you get the MongoDB server or that process running before you try to run this app. So we're just going to use the tutorial database, and then these options here are just set because when you run the application, Mongo is going to complain about it if you don't put these. So that is all we've got, and we create the connection right here. So the connection represents our database connection, and then down here we have some pretty familiar JSON and URL encoded middleware, which is going to allow the Express server to parse the different request types. So that just pertains to the type of responses that we're getting on the server. And then finally, we have things related to the session itself, which we're going to dive in a little bit deeper. And at the bottom, we've just got, we're listening on localhost 3000, and we have one simple route for the home page, just says hello world sessions. So that is our app. This is the only file we're working with, and so it should be pretty straightforward. Like I said, this tutorial is not an Express tutorial, and I assume that you already have a decent understanding of how the Express framework works. I'm trying to stick primarily to how the Express session middleware works. So if you don't understand how Express works or how middleware works, be sure to check out some of my other videos or just read some of the documentation online. Before we get into any of the configuration and understanding how the Express session works, we need to answer the question, what is the difference between a session and a cookie? You'll see that in the configuration I've got a cookie set, and in a previous video that I did, again, link is in the description, we talked about what a cookie was. So basically a session and a cookie are different in the places that their data is stored. So a cookie has its data stored in the browser, and that browser is going to attach that cookie key value pair to every HTTP request that it does. A session, on the other hand, is going to be stored on the server side. So when I say server side, just the Express.js application. And so this Express session is going to store a little bit bigger types of data. So in a cookie, you can't put a whole lot of data, and it gets very tedious if we're constantly adding more and more data to the cookie that we're attaching to each request. So it would make sense to put that in a server-side session where we can store much larger amounts of data. In addition, a server-side session is advantageous because with a cookie, we cannot store any sort of user credentials or secret information. If we did that, then a hacker could easily get a hold of that information and steal personal data. So the benefit of a session is basically the fact that we have it on our server side and we're actually authenticating into the session with a secret key. So with that said, that is the main difference between a cookie and a session, and I want you to keep that in mind as we're talking about the two in this video. Now that that's covered, we have some time to get into the actual code and configuration of an Express session, and then I'm going to show you kind of how it works in real time. So what we've got on the screen right now is the Express session documentation. It's just an NPM module, a pretty popular one at that, and you can see on npmjs.com there's all the documentation that you would need to learn how to use this. But I'll just point you towards a few of the common things that you'll see. First off, of course, we require in the Express session, and then these options right here are what are going to be included in that options object. So if you look at the code here, you'll see that for our session, we're saying app.use, so that's just we want to use the session middleware, and then we've passed into the session middleware an object right here which represents our options. So if we go back to the documentation really quickly, you'll see that all of these options are documented right here under the options section. Now the one thing that I wanted to point out, you get through the options, that's great, fine, but then you get to the bottom somewhere down here and it talks about a session store implementation. So if you're unfamiliar with what that is, it's basically deciding what persistent memory are we going to store our sessions in. If you remember from a few minutes ago, I said that a session is used to store information about a particular user moving throughout the browser or a client. And so we can potentially get up to a decent amount of information, and therefore in a production environment it would be useful to have an actual database storing that information. Now by default the Express session middleware just comes with its own implementation of a session store, but it's not using a database, it's just using in-memory or memory that's local to your application, and it's not going to be a scalable solution. So what we need to do is set up an actual session store, which is a fancy way of saying we need to connect our database to the Express session middleware. So there's going to be a lot of options for what session stores we can use, and they're documented here at the bottom. The one that we're using particularly is the Connect Mongo session store, which is probably one of the most popular ones, and it allows us right here to connect to the MongoDB database that we have running in our Express app. So let's go back to our app real quick and see what I mean. So to do this session store, to connect it up, we first have to have our database connection. So we talked about this a few minutes ago. Here's our connection. We're just using a tutorial database on localhost. Nothing, you'd obviously want to change this if you were in production. But we've got this running on my computer, and I can actually come down to the terminal here and run the Mongo shell. And you'll see that we can show DBs, and you'll see that we have a tutorial DB set up when we connected to this database. Now what we want to do is we want to tell the Express session middleware that we want to use that MongoDB database for its session store. So you'll see that that happens right here in the store option of the session middleware. And so what we've done is we've passed in the session store object into this store option. And the session store object is set up right here, and it is basically just using that connect Mongo right here, the connect Mongo package, and we're configuring a few options. We're saying that the connection equals the connection that we just set up, and the collection that we'll be putting our sessions in is going to be called sessions. Pretty standard option that we have here. You can obviously customize it a little bit, and if you went to the documentation of Connect Mongo, there's a few other options that you can set. But what I want to show you is what is happening when we connect everything up. So in my first terminal, I will run this application. So let me go to the path here, and we're going to run the application. So we are listening on localhost 3000, and if we come into the browser here, I've got this queued up so that we currently have localhost 3000 ready to go, but I have not clicked refresh yet. The reason being is because I want to show you exactly what this middleware, the session middleware, is doing. So let's first come back to our code, and what we want to do is go to the Mongo shell, and we want to use the tutorial database. So now we've switched to the tutorial database. Let me clear the screen, and we're going to show the collections that exist in that database. When I ran the app, it initialized this sessions collection in my database. But if I say db.sessions.find, there's going to only be a couple objects in here. Let me just go ahead and drop this really quick because I think I had some stuff from previously. So let's just say db.sessions.drop. So we dropped the database. If we show the collections now, there's nothing. But if we were to come here and refresh the app, so we're using NodeMon, so if we click save, it's going to refresh the app. We're going to go into Mongo, show collections, and you see again that the sessions have been established. And if we say db.sessions.find, we shouldn't find any documents whatsoever in this collection. So we have a completely clean slate, and in order to establish a new session, all we have to do is make some sort of HTTP request to our application. So if I came to the browser and I clicked refresh here, what's going to happen is that session middleware is going to kind of fire, it's going to create a session, and then what it's going to do is create a session ID, which is going to be stored in a cookie in this browser. So just like we don't have any sessions in the database yet, we also don't have any cookies in the browser yet. So let's go back to our code, and what I'm going to do is just walk you through a few of the options, and then we'll finally see exactly how it's working. So when we set up our session middleware, we have a secret. Pretty self-explanatory, but this secret is going to, usually it's going to be stored in an environment variable, and you don't want to expose this to the public because it basically says if the secret is invalid, then the session is invalid too. But in this case, I just put some secret just so that we can have it all in front of us. Then we have a couple options here, resave and save uninitialized. And these are just options relating to what does the session do if nothing is changed? What does the session do, if something is changed? And basically tells the middleware how to react to different events in the browser. You can read up on the documentation a little bit more on these options. But the thing that we're interested in, we already talked about the session store, but what we're doing is we're setting a cookie max age. So in other words, like we talked about in a previous video, a cookie can have an expires header, or not a header, but an expires property, which says after a certain amount of time, the browser is going to delete the cookie and it's not going to attach to any of the requests in the future. So in this case, we're setting our cookie equal to 1 day. And you can see the math that we're doing here in the comment. We're basically just saying 1 day, 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute, and 1,000 milliseconds in a second. And so that's the math that we're doing right here to get to a full day for that expires property. So basically what's going to happen when I send an HTTP GET request to our sole route right here is the session middleware is going to initialize a session, and then it's going to take that session ID and set it equal to this, or set the cookie equal to that session ID. The cookie is then going to be put in the set cookie header, HTTP header, and then that is going to be in the response header. It's going to go in the browser. The browser is going to receive it and say, oh, you want me to set this cookie? I'll set the cookie, and now every time we refresh, that cookie will be a part of that request. So let's go ahead and do this. We're going to visit our only route in the application, and to do that, we need to go to Google Chrome, and we're going to click refresh. So when we clicked, well, now it did not load, so let me go ahead and do that one more time. We refreshed it, we get our response. It says hello world sessions, and what you'll notice is now we have this cookie, which is by default called connect.sid in the express session middleware, and we have some sort of value here which somehow corresponds to our session ID. So basically what's happening is the express session middleware is going to get this cookie on every request. It's going to take the value of that cookie. It's going to say, okay, look up this session ID in the session store, which is the database, and then it's going to say, is the session valid? If so, let's use the information from the session to either authenticate our user, find out some data about our user, maybe like how many times that user has visited our site. Anything of that sort is what's going to happen when the user loads a different route. You'll also see that we have an expires property right here that says tomorrow this cookie is going to delete from the browser. But for now, since it's still valid, it's going to attach to every single request. So if we go to the network and look at that last request, we'll see that in the response header, this came from our Express server using the Express session middleware, we have the set cookie header. And we set the connect.sid header and we gave it an expires. Now in the request headers, since we only did this once, you won't see any cookie. But if I click refresh one more time, and we look at the request headers and response headers, you'll see that in the request headers, we have the cookie that was set previously. So in other words, the browser is saying, okay, I have a cookie that is still valid. Let me attach it to every request within this localhost domain. All right, so we have this cookie on every request now. Let's see what's happening on the back end. So let's go back to our code. And we're in the Mongo shell, so we're looking at our database right now. And we're going to type in db, well, let me clear this real quick, db.sessions.find. and that's going to look in the sessions collection for any documents in that collection. And you'll see that we have one and only one document, which represents the session that we just established in the browser. So you'll see that the ID is right here, which you can also see in that cookie that we have in the browser. So let's see, the first couple letters were capital AYYJ. So let's go back to the browser, and you'll see that the cookie right here has got that ID set in it. So that's how we kind of connect the back end to the front end. And then let's once again come back to our code. So we also have the expires header within here, so we can also validate it on the back end. And basically what this is going to do is every time the server gets that specific cookie with that session ID attached to it, it's going to come to this sessions collection in the database. It's going to grab that document out of the database or the session store, and it's going to get information that we have set onto that session and use it to do whatever we want to do with our application. Now this is great and all, but what do we actually use this Express Session middleware for? Well, in another video in this Passport.js series, you'll see how Passport.js actually connects in to the Express Session middleware and uses the session to actually authenticate the user. But since this is kind of a standalone video, I'm not going to get into that. All I'm going to show you before we kind of conclude is where this session is being set. Now, we know that the cookie in the browser has the session ID, and we use that session ID to look up the session in the database or the session store. Now, we can also come to our routes and get information about the session. So if we said console.log request.session, you'll get to see exactly what that session looks like, and we can actually set properties to that session. So again, I'm connected using NodeMon, so we'll automatically refresh when we save this app. So let me click Control S to save. You'll see that something happens here, so we reset, and now if we visit this route again in the browser, in the console we should see the session object. So let's quickly switch over to the browser. We'll refresh this page, and then we'll come back to our code window, and you'll see that our session object has been printed to the console. Right now all we have is a expires header and a couple other metadata properties, but what we could also, and this is set to the cookie object, but we could also set other information. So we could set something like how many visits a user has made to our page. So let's go ahead and do something really simple like that. In our only route that we have for this application, let's just say if request.session.view count, we want to say request.session.view count equals request.session.view count plus 1. Or you could just do the plus syntax at the end. You could just do something like that and be done with it. But we'll be really explicit here, and we'll set a value. Okay, so if we have that property on the session, we're going to increment it by 1. And then what we're going to do is we're going to say in the response, instead of hello world, we're going to say you have visited this page X amount of times. So we'll use a little JavaScript syntax, and we need to change these to backticks to get this to work. And let's see, we can just put in request.session.view count, and now it should tell us how many times we've visited this page when we visit that page. Now we also have to say else, because in this first occurrence we're not going to have this property set. So if that does not exist, then we're going to say request.session.viewCount equals 1. All right, so we have set a property to the session object, and let's go ahead and save this application and go to the browser and visit it. So we're in the browser now, and we will reload, and it says you have visited this page 1 time, or it should be time. But now, every time we refresh, we're going to get that number to increment because of the logic that we've put into our route. So you can see how this session object could be very useful for tracking information about a specific user or client. One last thing I want to show you, if we go back to the code, you can look it up in the database again. So let's go back to Mongo and let's find that session once more. You'll see we still have just one object, one document in the database, but now we have this little property down here. So when we set the view count property on the request.session object, that actually persisted in the session store or our MongoDB database under the view count property. So again, you can see how powerful this is, and you could also kind of extrapolate out and start to foreshadow how something like a Passport.js middleware could kind of connect into this express session middleware to keep its own sort of data. You came here to learn user authentication, and it took us about 2 hours to get to the part where we're actually writing it for the first time. I hope the prerequisite lessons that we just covered were really helpful to get us set up to this point. And now we're ready to actually implement the Passport local strategy. Within your web app, your users are going to have the expectation that you have the option to do a username or email-based authentication. You have to have this because what if your user doesn't have a Google account or a Facebook account to use that, other authentication option that you're offering? You've got to have this most basic option for them, and the Passport local strategy is one way to do it. Equipped with our knowledge of HTTP headers, cookies, the Express session library, and Express middleware, we are fully ready to jump into this strategy. My goal in this video is to get the Passport.js library imported into our Express.js application and can start to configure it. To help us with this, I've set up a repository on my GitHub that will basically give you a starter template to work from. And what this is going to do is kind of eliminate all of that stuff that we don't want to focus on, such as setting up a basic Express application, setting up a very basic database with MongoDB, and even setting up something like a Express session, which we talked about in one of the prerequisite videos for this tutorial series. In this repository, I've got 3 branches, but the master branch is going to have your starter template. So if you don't know how to use branches in Git, that's totally fine. If you do want to learn more about that, I actually have a full tutorial series on using Git. But anyways, you can see if you come into GitHub, you don't have to actually know any commands to do this. You just drop down and you can see that the different branches will have the final branch is kind of the final implementation. No promises that we'll get line by line, character by character to the same implementation here during the video, but we'll come very close. The overall structure will be exactly the same. And then we have the final all-in-one, which is basically just one JS file or JavaScript file that has everything that you need to run this with tons of comments so that you can really figure out what is going on. So that's what the repository is. You can go ahead and fork it or clone it, whatever you want to do, and then download it to your computer. And once you've done that, you should land to a screen like the one I've got right here. And I've got open the README, which kind of gives you basic instructions on how to use it. We went through most of this already. So let's go ahead and close that out and take a quick tour of what's going on in this repository, and then we will go into the configuration of the Passport local strategy. Let's take a quick look at what I've got for you already set up in the template application. It's pretty similar to what you probably have seen before. I tried to make it a similar structure to what you might find in a lot of online Express Node.js tutorials, so hopefully this looks a little bit familiar. But anyways, we start with our app.js, which is going to set up our basic Express app. So the imports at the top, let's just go through them real quick. If you haven't installed them, after cloning the repo, just type npm install to get those installed. We have Express, pretty straightforward. Mongoose, which is the ODM for MongoDB. I will mention, while we're on this line, I've already got my MongoD service running in the background. So you'll have to do that when you're running this app. And I don't even know if I have this in the README. So maybe I will put that in here right now. We'll just say make sure to run the MongoD service before running the app locally. Alright, so now that we got that covered, just make sure that you have that running, and then you should be able to run this app just fine. Alright, so moving on, we have Express Session, which I've covered in a separate video, how this works and how to set it up. So I've already implemented it here for you. If you want to learn more about that, go to that video. Again, that is in the description. Just click on the playlist and you'll find it. So next up is Passport. This is what most of this video and the next couple videos is going to be about. We'll require in the built-in Node.js crypto library, which is going to allow us to create and verify passwords. We require in the routes, which is the routes folder. We'll get there in just a second. And also we have a database configuration in the config directory. Now coming down, we have Mongo Store directly related to the Express Session middleware. Again, that's another video. We have this little line right here. Most people probably have seen it, but if you haven't, all this is doing is giving us access to the .env file that we have defined over here. That by default is not going to be imported when you clone this repository because it's got secret keys in it. So you will need to create the .env file, and in the .env file, I think you only need two things. You need the DB string and the secret. And for my case, I'm just using a very simple DB string. I don't even have a user or a password, just to keep things simple for now. But in production, you'd obviously want to have a user and password in the actual database that you would connect to. So, and then the secret is going to be, I think, for the Express Session module. So let's close that, and then you can see you can actually get access to those variables anywhere within this app.js file with this syntax, the process.env.variable name. Alright, so moving on, we have the Express application, pretty simple. This is some middleware for parsing HTTP responses. Most of you would probably have seen app.use body parser.json, but I've just used the built-in Express parsers because I think these actually came in a little bit recently in like a recent release. I could be wrong on that, but you no longer need to use body parser. Alright, session setup. Again, this was covered in a different video, but let's just take a very quick look at what is going on here. We have our session store, which is going to say, hey, Express Session middleware, I want you to use the MongoDB database for the session storage. And in that, I want you to use the sessions table, or not table, but collection in that MongoDB database. So that's the session store. Down here in the configuration options for the session middleware, we are telling it to use that store. Then we have some other options here. So the secret, we just talked about that. That's going to help the Express session middleware validate the session that it has looked up. It's going to check to see if it matches that secret. These two options have to do with, how does the session treat or how does the session react when there's actually no changes in the browser. You can read up about that on your own. And then finally, the cookie. This is also another separate video in this series, but basically what we're doing is we're storing the session ID in a cookie in the browser, and this right here is just going to kind of tell the Express session middleware, hey, I want you to basically set an expires header, not header, but an expires property of 1 day. So this cookie will expire in 1 day, and a new session will have to be reestablished when it does expire. All right, that was just a quick overview. If you want more, you'll have to check out the other video. Next up, we have Passport authentication. I've just put in this basic require statement to show you where it is. So it's in the config directory. We'll get to that in just a moment. We are using our routes. So this is pretty standard in Express. You put your routes after the other middleware, but before your error handler. In this case, we don't have an error handler. You might want to do that for a production application. Finally, we are listening on port 3000 localhost. Pretty straightforward. So that is the basic app. Let's go ahead and look at some of the other pieces. So let me save that. We'll first start in the config. So we have Passport.js. All I've done here is imported the relevant modules that we'll need to set it up. And then I've imported some database configurations, the connection, and then the user model that we'll be using. So going straight over to the database configuration, this is a pretty standard MongoDB database setup. We're requiring in Mongoose. Again, we got this access to the .env file. We're going to grab the DB string from that file, and we're going to create a connection with it. So we pass in the string to the create connection method on the Mongoose object, and then we pass in these options, which will just suppress any warning messages. Finally, we have a user schema. It's very simple. We just have a username, hash, and salt. You will see what the hash and salt mean a little bit later. So we create a model for that user based on the schema, and we export the connection so that we can use it in other files. So pretty straightforward with that. Let's see what else we've got. We have the password utils, which should just have the validate password and create password functions. So let's check that out. And you can see that I've already kind of templated out what the functions will look like. All we have to do is jump in there and actually implement them. Let's see if I'm missing anything else. Okay, I've got the routes, just one route file. And I know there's a lot of stuff in here, but really there's not much of anything. We pass in the Express router, Passport, because we're going to actually use Passport in our routes. We have some password utils we just looked at, the database connection and user model. And really what we're going to be doing, the only thing we're going to be doing in this file is these two routes. So the login and register route, we're going to have to implement the logic behind these. In the get routes below, all I've done is create a super simple flow that we'll go through as we implement this Passport authentication. So you'll see the home page is just going to tell you to please register. You'll click the link, goes to the register page, which is right here. That has just a really ugly looking form that we will type a username and password into to register. That will submit to our custom implemented post request up here. Then it will, if you're successful, it will redirect you, I think, to the login page. Then you will log in with your username and password, which will create a post request to the login post route, which we have to implement. And if you successfully log in, I think it will redirect you. We're going to have to write this logic, but it will redirect you to, I believe the login success route. So it'll say you've successfully logged in. Then we'll try to visit a protected route, and that will be right here. And we're going to check if we're authenticated and let you in if you are. So basically, you can look at this, but it's just a flow of pages that we're loading. The reason I did this without using something like EJS or another templating language is just to keep it as simple as possible. All we're doing is passing basic HTML and HTML forms and using the built-in express methods like res.send and res.redirect. So hopefully that makes sense. If it doesn't, take a look at this for a few minutes, and I know it will. Before we get into the actual implementation and configuration of Passport, I wanted to show you again, I know we already touched on this in the first video just for a few minutes, but I want to show you how to find the documentation for this. I personally had a very difficult time finding kind of an end-to-end tutorial and documentation for Passport, and I think since all the strategies are developed by different developers, there's not really, a one-size-fits-all documentation for it. Now, if you go to the Passport.js website, you'll first find that you can click strategies and browse through all the different strategies. You'll be able to go to those pages. But in our case, we're using the Passport local strategy. So if we click this, we should be redirected to the Passport local strategy. It's going to give us some basic usage instructions. So we install it, we configure it with a verify function, and then we can use it in the route here. But that's pretty much all that it gives us. There's actually a couple more steps that you need to do to use the local strategy, which is kind of weird why it's not in this on this page. And if you click on the examples, it goes to a 404 page. I think maybe that was recent, I don't know. Whatever the case, this is actually not where you're going to want to go for documentation on the Passport local strategy. The Passport local strategy is actually better documented in the general documentation of the Passport.js middleware. So if you go to documentation right here and you click username and password, this is where you're going to get a little bit more verbose documentation on the Passport local module. So here we have the same thing, install Passport local, but here we're getting a little bit more detailed implementation of this verify callback and how you would use the form, how you would use it on the route, what kind of parameters you can pass to the verify callback. So this is a little bit better documentation, but it still kind of misses some of the configuration that you have to do for this module. So I'm going to show you exactly how to use it, but you can kind of peruse the Passport.js documentation. You'll find a few things. For example, if we click on configure, it's going to tell us how to configure a strategy because being a framework for the middleware, Passport has kind of a standardized way to integrate different strategies. So on every single strategy that we use, we're going to need a verify callback. So in this section, it kind of talks about that verify callback and what the different responses are required based on how the user whether the user entered the correct or incorrect credentials, whether we got an error message, whatever the case, it tells you that. And then we also have documentation on the authenticate method. So Passport actually provides you with a built-in authenticate method on the Passport object, and all you need to do is provide it with the name of the strategy that you've defined, and then Passport figures out how to go find the verify callback that you've configured for that specific strategy. I know this sounds like a lot, and I know this documentation is a little bit sporadic. It's not necessarily, A, B, C, D, 1, 2, 3, 4. It's a little bit confusing. So let's just get into the implementation, and I'll do my best to kind of document the Passport local strategy for you. Like we saw in the documentation, the first thing we need to do is define the verify callback for the Passport local strategy. So we'll do this in the Passport config file, and all we need to do is comment this out, the Passport.use method, and pass in the strategy and the verify callback. So I'm just going to paste in the full thing real quick, and you'll see that this looks pretty similar to what we saw in the documentation. It's also going to be pretty similar to what you'll see in a lot of tutorials. But I personally find this a bit confusing when we're looking at it all at once. So let's go ahead and deconstruct what's going on in this configuration, put it in some variables so that we know exactly what's going on. Alright, so the first thing that we need to do is define the strategy itself. So let's say strategy equals, and then in this case it's going to be the new local strategy. Alright, so that is the most basic way to create a strategy, and then this strategy is going to require that verify callback. So let's define that above here. And the verify callback is going to take a couple parameters. It's going to take a username, password, and done function. In this case down here I just called it callback, but it doesn't really matter what you call this. All you need to know is that this represents a function that you will eventually pass the results of your authentication to. So those are the parameters, and they will actually be populated by the Passport framework based on how you implement this. So we expect the username to be the value that we received from the request body of some sort of login form. So if we were to create a login form, type in our username and password, and then make a post request to the Express API, that post request is going to have a username and password field, and Passport is going to automatically look for those two fields and grab the values of them and populate them in the verify callback. Now there's a little bit tricky part to this, because if you don't name your username and password fields exactly this, username and password, the Passport framework is not going to, or not the Passport framework, but the Passport local strategy is not going to know what variable to look for. So in order to prevent this, we can actually define custom fields that we want Passport to look in. I'll show you how to include this in a few seconds, but first let's just get it in a variable. So we'll say custom fields is equal to an object, and we'll say the username field is going to be uname. We're just making this up, making it custom so that we can see exactly how this works. So our username field is uname, and then our password field is just going to be something like PW. So obviously these are some non-conventional ways to name the password and username fields, but if we define them in our custom fields object, then Passport local will know where to look. All right, so we'll use that object in just a second, but first let's come back to the verify callback. So in the verify callback, what we're doing is basically our own implementation of a password verification. Now this is where I think people get tripped up a little bit. I know I did, thinking that the verify callback has to be a very specific structure and we have to use a certain database because of course the documentation online shows that we're using the MongoDB database, but in reality it doesn't matter what database you use, and it really doesn't matter how you choose to verify the credentials. All that matters is that the return values that you pass to this done callback are what Passport expects. So we can come in here and do whatever we want, but for simplicity, as we know, I'm using the MongoDB database, so it's going to look pretty similar to what you saw in some of the examples. So let's go ahead and copy this. So I think we're done here with this copy paste, and then we can put it right here, and all we're doing is going to the MongoDB database and we're looking for a user that has the username provided in this parameter. So again, what's going to happen, we make a post request and we provide a JSON body with uname and password. Then Passport as a middleware is going to look for these two fields, finds them, takes the value and populates these two parameters with those two values. So at this time, when we're executing this callback, these represent the username and password, so we can look up the username in the database, and then just in a basic promise, we are returning the user. So we check if there's a user in the database, if someone has actually registered already, then, or actually it's the opposite. If there's not a user in the database, then we are just going to return, this should be updated to done to represent this done callback up here. And what we're telling Passport here is that no, there was not an error in this operation, but there was also not a user. So go ahead and reject this, and so Passport will return, I believe it's a 401 unauthorized HTTP status. So that's the first check we need to do. Then we need to check whether this is valid. Sorry for all these comments, I had them in here before when I was writing this out. So we have a variable here that says is valid, and for right now we don't know how this works, and this is not even a function that we've defined yet. But basically what we're doing, we can comment this out for, well, let's not comment it out yet. What we're doing is we're putting the password through some sort of verification function, which is going to, or we're also putting the hash and the salt stored in the user record in the database, and we're verifying those two things against the password. You'll see how that works in a minute, but basically let's just assume that this returns true or false, which it does, and we say if the password, if the login credentials are valid, then we're going to return the callback. Let me update this real quick. Again, these are just corresponding to this parameter that Passport provides. We're going to say nope, there was no error, and yep, there was a user, and this user was successfully authenticated based on my verification function. So when we pass this to Passport, it's going to let us into the route. And then finally, if it's not valid, we say nope, there was no error, but we did not verify this user correctly, don't let them in the route. And then finally, we, using the promise syntax, we're just going to catch any of the errors that happen within the Express application, maybe on the database side of things. And if we get an error, we're just going to pass that to Passport, and it knows how to handle that. So that is the basic verify callback, and I'll show you really quickly what is actually going to happen here when we use it in a route. So let me save that and come back to one of our routes. So let's go down to the post login route. So what we're going to do is include a middleware in the post login route called Passport.authenticate, and then in the authenticate we're going to say the local strategy, and we're going to pass in well, we can worry about the rest of this a little bit later. All I wanted to show you here is that we're passing this middleware in the login post route. And so basically what's going to happen is we make a post request to login with our username and password. And then that gets intercepted by the Passport middleware. And then we come in, Passport populates these two objects. It runs this function. So we're looking up the user in the database, validating the credentials, returning some sort of response. And if we get this response right here, where we populate a user, then it's going to go to the next part of this function and it lets us in the route. So that is the basic implementation of Passport, and now we're going to tie up some loose ends and make sure that it actually works, and then we'll see it run live. We just have a few more things we have to do to get this working. The first thing I forgot to do when we finish this up is actually complete this verify callback. So we started with passport.use, and then we passed in all of this stuff, so we need to actually do this now. So the first thing that we need to do is, let's see, we have our custom fields and our verify callback. So in our new local strategy, we're going to pass in our custom fields and our verify callback. And then we're going to say passport.use, and then we're going to pass it in that local strategy. So now we actually have it configured, and in app.js, when we require it in somewhere, let's see, where do we do this? Right here in the Passport authentication, we require in the configuration, and what that's going to do is basically just take this line right here and include it in the app.js. Now that we've got our strategy configured, we've done the bulk of the work. There are a few extra things that we're going to have to put in here, but I'm going to go ahead and just copy them in, and then we're going to come back to them a little bit later after we have everything working to understand them a little bit better. So at the bottom of this configuration, I'm just going to paste in two initializations, and this is the passport.serialize user and deserialize user. Now this has to do with the express session and how we put a user into the session and grab a user out of the session. Basically what is happening is we're going to put the user ID into the session, and then we're going to, when we want the user to come out of the session, we will grab that user ID that was stored there and find it in the database. Again, we're going to come back to this, so don't worry about it if you don't understand it. I think these two functions are a little bit tricky, especially because there's not a whole lot of documentation around them. So let's save that. Let me save this real quick. Let's come back to app.js and add in our last two lines that we're going to need before all of this is going to work. So right after we require in the passport configuration, we're going to say app.use passport.initialize. And again, what this is going to do is kind of initialize the passport middleware, and basically so that it doesn't get stale. So we might be using different routes. We might click to several different routes, and if we don't reinitialize the passport middleware, then there's a chance that, hey, maybe the user, maybe their session expired or something, in the time that we're doing that. It's just always safe to refresh the Passport middleware every single time that we load a route. And so that's what this is doing. And then we need to put in Passport.session, which has to do a little bit with what we just talked about, the serialize and deserialize user, but more so it has to do with the actual express session middleware. So I know we talked about this a little bit earlier. We also talked about it in a separate video, but the express session gives us access to the request.session object, and anything that we store on the request.session object inside any of the routes is going to be persisted to the database under the sessions collection. So knowing this, Passport cleverly kind of plugs into that and bootstraps off it and uses it as a user authentication mechanism. So we're going to actually go through this along with the serialize and deserialize user in a few minutes, but for now let's see if we've got this working. We still have a few things to do in the routes before it's going to work, but let's save it and actually run the app. I'm going to run this with nodemon so we have live updates. So nodemon app.js, and doesn't look like we have any errors at the moment, so there's a chance that we have this working. The first thing that we're going to have to do before the Passport middleware is going to be effective is finish defining the password verification and generation functions. So if you remember in the Passport configuration, in this verify callback that we had defined, we called this method called valid password, but in this module we haven't actually created this valid password function, so it's not going to work as it stands right now. We're going to have to go over to our password utils file and define both the valid password and the gen password functions before anything's going to work. We're going to open up password utils in the lib folder, and you'll see that I have basically templated out the two functions that we're going to need. But to understand this, I've actually put a slide together so that you can visualize what's actually happening with the generate and validate password functions. We're going to be using the Node.js crypto library to do this, but before we get into the actual what methods we're using, it's better to have a conceptual understanding. On the screen right now is a basic representation of how we generate and validate a password to a database. Now, the cardinal rule here is that you're never going to store a plain text password in a database. That's kind of web application 101. I think everyone is pretty familiar with that, but actually figuring out how to do that is a little bit more complicated. Now, we talked about earlier how the Passport.js middleware does not give you a specific way that you need to do this. It gives you a lot of freedom as to how you might generate and validate the passwords that the users are providing in the login and register forms. As we go through this, just note that this is not the only way that you can go through this process. There are other libraries other than the Node.js built-in crypto library. There's also different types of logic that you can go through, but I've tried to keep it as standard as possible and kind of in line with what you would call best practice. So anyways, what's going on here is we have two steps in the process. So we have the creation of the password and the verification of the password. You can think of this as the register and the login. So you're sitting there behind your computer, you found this cool new web app, and the first thing that the web app is going to ask you to do is register. You need to give them a username and a password, and then maybe a couple other things like an email, first, last name, maybe even an address or something. But what's important is that you are providing that web app with a plain text password. You're just typing that into a field, and when the web app receives that password, it is still in plain text form. We can't really avoid that, that's fine, but what happens is we need to transform that into something that we can actually store securely in the database without worrying about some hacker, taking over a database and grabbing all the, users' passwords in that database. Once the user information is stored in the database, we can move on to step 2, which is password verification. Now in step 2, you can think of this as the login process. So when the user sits behind their computer and is typing in their username and password to log into your web app, that's going to be the verification step, and what's going to happen is they're going to provide you with their username, which you're going to take and you're going to look up that user in your database using the username or maybe an email. Once you find that user in the database, then you're going to have access to this password hash and the salt that we stored before. So you're going to pull both of those values out, and along with the password, the plain text password that the user just provided you, you're going to put those values through the same exact hash function. So you pull the salt out of the database from that user, and you put in the plain text password that they just typed in. And so in this case, we have the same exact values for these parameters as we did when we created the hash in the beginning. And we know, since a hash function is always going to give you the same exact value if you put the same parameters into it, we know that we can generate a password hash and compare it to the hash that we stored in the user record in the database. And if those two values match, then we know that we have validated this user and that they have entered the correct credentials. We've got a conceptual understanding of this process, so let's go ahead and code it. We're going to come back to VS Code. Again, I've set up the functions in the parameters that they require right here. And we're going to start with the generate password function, which is the step 1 of the process. So this password argument is going to come from the user when they type their password into the register form. And then here is our implementation. Now I'm going to walk you through this. We're using the Node.js crypto library. And the first thing that we're going to do with that is generate a salt, which is just a pseudo-random value, and it's going to add a bit of randomness to our generation of the hash. So we have the salt, then we pass in the plain text password and that salt to the pbkdf2 method on the crypto library. And then this last part, sync, just means synchronous for synchronous operation. And then the 10,000 right here is going to represent how many iterations we're doing. 64 is how long or how big this hash is going to be. And then right here we specify which hashing function we're going to use. Finally, we will convert this to a hexadecimal string. Now down here we just return those two values and we're done with this piece of the implementation. To learn a little bit more about what we just did, I'm going to pull up a document on Google. This is from the Internet Engineering Task Force, and it's just basically a specification for different cryptography methods or password-based cryptography methods. And if we go down to the table of contents, we can actually find the PBKDF2 specification, which is what we were using from the Node.js crypto library. And you'll see that this is actually going to, well, we might actually be in the wrong spot here. We're in the appendix. Let's see if we can get somewhere a little bit more straightforward. Oh, okay, we clicked on the wrong one here. So we need to click on 5.2. And this is going to show you kind of the template for implementing that kind of function. So the Node.js crypto library is just implementing this standard right here. and we can actually come up and see some information about it. So I think there's something on iteration count. It says that they recommend at least 1,000. We put in, well, you want to have 10 million for a super secure implementation. We are somewhere in the middle with 10,000, which should be fine. And then it also talks a little bit about the salt up here, and you can read up about what that actually is. A lot of this is just math, so I don't want to get into it, but this is kind of where the standard comes from. So we're not just using some random crypto function. This is kind of what the Internet Engineering Task Force has designated as this is how you should do it when you are verifying and generating passwords. We can now come back and do the second function, which is the valid password. I'm not really sure why I called it valid password. Probably should be validate password. But anyways, here is the implementation for that. All we're doing, this is basically the same exact thing. Remember what we went through on the slide. We're just creating the same exact hash that we did up here, except this time we're receiving the hash and the salt, or well, we're just passing the salt, but we're getting that salt from the user record in the database. And then we're getting this password when the user types it in the login form. So given the same inputs, we should expect the same output, and therefore we are going to return whether the hash that comes from the database is equal to the hash that we computed using the password that the user just provided us and the salt that was in the database for that user record. So we're going to either receive true or false, and this is what we're going to put in our Passport.js verify callback. So let's save this and come back to our Passport.js configuration. And you'll see that we're already using this right here. We've already set it up how we want to. We just need to import it. So I'll do that right now. So we'll say valid password equals require lib password utils dot valid password, because we've exported them here at the bottom. So now our Passport.js implementation is complete, and it should work with our application once we implement the 2 post routes for login and register. So let's do that right now. We'll come to the routes, and you'll see that we have the login and register routes. They're not implemented yet, so we need to do that. It's pretty simple, so I'm just going to paste in the implementation. Most of this is just creating a user record in the database, but we're also going to be implementing that first part, the gen password function, in this register route. I think I have it. Yep, I have this already imported, but let's go ahead and rename it. We'll just say gen password to stay consistent, and then we need to grab the gen password function off of the import. So now that we have that, we can implement this. So here's the implementation. We'll walk through it really quickly. I want to point out a few things before we get started. We are grabbing the password and username values from the request.body.pw and uname fields. If you remember from the passport configuration, just to demonstrate the options you can do, we went ahead and customized what we're expecting to see from that request.body object. So we need to stay consistent, and we need to use those to grab those values. So you can see what we're doing here is we are generating that salt hash object. So it's just an object with the salt and the hash. So this one right here. And that's coming from the gen password function that we just imported up here from the password utils. Then we are going to create a new user object for the database. We're going to save that user. We'll go ahead and just console log it to the terminal, and then we are going to redirect to the login route. All right, so we have implemented register, and we can go ahead and try that out in the browser. So let's run it. Run the application. Looks like we don't have any errors, so let's jump back to the browser. Type in localhost 3000 /register, or actually we can just go to the home page and it gives us a link to the register. We're going to enter our username and our password. I'll just do 123 to keep it simple, and we'll submit. It looks like it properly did something. Let's come back to the terminal to verify that. Good news, we see the object that we just created. We put the username in there and then the hash and the salt that we got from the gen password function. And then we can also check the database. So let me just open the Mongo shell and we'll look it up. So show databases. We are using the tutorial DB based on the .env file. So I will say use tutorial DB, and then we can say db.users.find, and you should see the user that we just created. So clearly we've got the user in the database, and the last thing that we need to do in this entire flow is implement the login route. So if we come back to, well, we're already in the file, we have the login route that we've already kind of put this passport.authenticate method in a little bit earlier, but I just want to add a few things to it, and we'll actually simplify this a little bit as well. The first thing I'm going to do is pass in a second argument to the authenticate method, and this is just going to be an object that tells Passport where to redirect based on the status of the login. So if you remember, the passport.authenticate method is literally just going to look in the Passport configuration for this verify callback, and it's going to call this function right here. And this is going to return either a user if we are validating the user correctly and the user has provided the correct password, or we're going to say false, and in that case it's going to redirect to the login failure. So really, since we're adding conditions for both a success and a failure, we don't need this last function right here. So we've just included this normal callback that we see in most express routes, but we don't need that in this implementation, and we are pretty much done with the login post request. So let's save this and give it a try in the browser. We'll type in the same user that I did earlier, 123 for the password, and submit. And it says that we have successfully logged in. So something worked here. Now we can go to the protected route. It says you are authenticated. We can log out and reload. Now we're not authenticated, and we can log in again. So we can just go in this circle here. It's kind of how I set it up so that we can see that flow. But I'm going to be talking a lot more about how this is actually working and how you can use the Passport middleware in your routes in the next video. But let's come back one more time to the code and just kind of take a look at the routes that we just went through. So we started at login. Login submitted the data that we put in there, and the Passport verify callback was called. We successfully validated the user, so we got to right here, and then we come to the route, the login post route, and we had a success. So we are going to come to the login success route. You can see the success redirect, login success. So we'll come down here somewhere. So we came to the login success, then it said go to the protected route, so we clicked that link, and we came right here, which you'll see a little bit of extra syntax. We're going to go through this in the next video, but this is how we would authenticate the user once we've run through that authentication flow in the login post route. And then we can also log out. So we've got a logout method on the request object, and then the cycle kind of repeats. We are officially done with the Passport configuration. We've got it working completely, and this is all you're going to have to do for the Passport local strategy to authenticate users into your web app. Now, I did mention earlier that we were going to come back to something, and it was in the Passport configuration here at the bottom. So these two methods, the Passport.serialize and deserialize, and then also, I think in app.js, we have these two lines, the initialize and session. Now, we don't really know how those are working, and I promise that we'll come back and explain how those are working and kind of see it for ourselves in code. I would also like to go through some of these things like request.logout and request.isAuthenticated and understand what is going on there, and also kind of understand, you would intuitively think, well, we're probably just going to use the Passport.authenticate middleware on every single route that we want to authenticate, but that's not the case for the Passport local strategy. So to start, what we're going to have to understand is that Passport.serialize and deserialize configurations. So if we open up the Passport file, it's these two configurations right here that we need to understand to really grasp what Passport is trying to do. In order to understand this a little bit better, I'm going to open up app.js, and we're going to write a very basic middleware that is just going to give us, it's not going to do anything, but it's going to give us a little bit of debugging power. So we've got these middlewares working, so here's where we set up the session. So we include that here, then we include the Passport.initialize and Passport.session middlewares right here. So after those have done their work, these are happening on every single route request, we'll put in our custom middleware. So we'll say app.use, and we're going to pass in a simple function. We're just going to give it the standard parameters, and then what we're going to do in the body of it is just console.log request.session, and then we will console.log request.user. So you'll see how this works. The express session is going to create this object right here, and the Passport middleware should create this object here. And then finally we have to call next so it doesn't crash our routes. But basically every time we visit any route in this application, this is going to run, and we're going to see exactly how it's working. So for starters, let's just get this running and visit in the browser. So we'll come to Google Chrome. We'll come back to what I've got on the screen here in a second. Let's just go to the base route. So we're at the home page, and you can see in the application, here is our cookie that we've set, which represents the express session ID. So that will, we're going to just delete this really quick so that we refresh everything. So now we have a clean slate, and the express session middleware is going to recreate a new session for us to use when we press refresh. So we pressed refresh, it created a new session, and in the console we should see that printed out because of the middleware that we just wrote right here. So you see the session is going to show us the cookie, and that's pretty much it. You'll notice that the request.user object is undefined right now, and that is because we haven't yet authenticated our user using the Passport.authenticate method. So let's do that really quickly in the browser. So we need to actually just visit the login route because we've already got this user in the database, if you remember from last video. So we will sign in and click submit, and this is the same session ID. Come back to the code, and this time we've got a different story. So this time, let me expand this so that we can see it. So here was our first go around, so this is what it printed, and then this is the second time. So now we have the session with the cookie, but we also have this line right here. And this was created by the Passport middleware, and when we executed the Passport.authenticate method, which is in the login post route, so right here, that's what we just did. And what Passport did behind the scenes was create this additional property on the express session. And how we got this right here is through the Passport.serialize user function. So right here, we ran the serialize user function, we passed in the user ID, and we stored it under the user property. So let's go ahead and check to see if this is the actual ID of our user. So it's 5E0F. Now let's go over to the Mongo shell, and we're already set up to query this, so we'll say db.users.find, and you'll see that we have the 5E0F user in the database. So the serialize user function, when we did the Passport.authenticate method, is going to grab that user from the database, get the ID of the user, and then insert that into the Passport.user, or actually it would be the request.session.passport.user property. So now when we need to grab this user from the session, we're going to use the deserialize user function. So we're kind of seeing it all at once, but to populate the request.user right here, this is the middleware that we just wrote to print all of this stuff to the terminal. In order to populate the request.user, we are going to grab the user from the database right here, and based on the user ID that was provided in the session object, and then we are going to attach the found user to the request.user object. So that was a mouthful, and we've got a few more pieces to this puzzle. So we'll come to app.js, and these two lines are playing into this equation as well. So when we say passport.initialize, that's going to kind of rerun everything that we just did. And then the passport.session is going to kind of work in the same way. So every time we load a route, these two middlewares are going to work together, and what they're going to basically do is they're first going to check to see if this user property is not null. So it would look something like this. We would say if request.session.passport.user not equal to null, then we are going to know that there is a logged in user, and we're going to grab this user ID from that property. Then once we grab that user ID from the property, we're going to use the deserialize user method, pass in the user ID, grab it from the database, and then what we're going to do is populate the request.user and set it equal to whatever user we got from the database. So that's basically what is happening on every single route request. Now, if this user object is null, then that means that the user is not currently logged in, and we do not grab the user from the session, and this property request.user is not populated. If we go in the browser and we do the logout function, or we visit the logout route, you're going to notice the next time that we console.log these two properties that this user object is not going to exist. So let's scroll to the bottom, save this, come up here. So we're at the bottom. Let's go to the browser, and first we got to visit the protected route, and when we click this button right here, it's going to log us out. So we click log out and reload and come back to the terminal, and now you'll see that this passport object is going to not have this user property. In other words, we are not logged in. Now you might say, okay, this is a lot to look at, and it's a lot of kind of funky logic to go through every time we want to figure out if our user is logged in or not. And luckily we have some methods built onto this request object to kind of do this logic for us. These methods were defined by the Passport middleware, or the Passport local middleware, and we can see this if we visit the repository. So this module, the request.js module, is where this is going to kind of happen, or where these are defined. And you'll see a couple properties attached to the request object. So the first one is the login property, and this is actually called by default when we use the passport.authenticate method. So we don't really have to ever use this on our own if we're using the passport.authenticate method. Now what's useful to us is the last three properties. So first we have request.logout. So anytime that we want to log our user out, we just call this method, and you'll see that I do this when we had clicked that logout button. You'll see in the route for the logout route, somewhere down here. So here's my logout route, and you can see that I have called that method right there, which is basically going to delete the request.session.passport.user property from the session. So that's all that that's doing, and then next time we call the passport.initialize and passport.session middlewares, which happens on every route, it's going to check that property, see that it's null, and pretty much declare that the user has been logged out. Alright, so the next one we have is the request.isAuthenticated. And this is a really common one we're going to use a lot. And basically all this is doing is what we went through manually, and there's a bunch of funky code here because it's part of the framework, but basically all this code is doing is saying, does the request.session.passport.user property exist and it is not null? And if that is the case, then we declare that the user is authenticated, because the only way that that property would have been populated is after we use the passport.authenticate method, which is going to run the verify callback, which is going to implement our custom login logic. Finally, we have request.isUnauthenticated. I don't really use this. It's just the opposite of the request.isAuthenticated. So you can use it, but it's not really all that complicated. So we've got these methods. Unfortunately, these are not documented very well in the Passport documentation, which is kind of a shame. But anyways, let's come back to our code and see how we might use these properties to our advantage. So right now in our routes, we are manually calling these things, and right here we are manually checking whether the request is authenticated, and then if it is, we are doing something. If it's not, we are doing something else. So in order to streamline this a little bit, it would make a little bit more sense if we included this as middleware, and all we're doing is checking if the user is authenticated, and if the user is authenticated, we just call the next callback and it goes into the route. And if the user is not authenticated, we return some sort of 401 unauthorized error. So to make our lives a lot easier, let's go in the routes folder. You can really put this anywhere. I'm just going to put it in the routes folder, and we'll just say auth middleware.js. And in the auth middleware.js, I'll just take you through two different middlewares that we could implement. You can get as creative as you want with this, but here are some pretty standard ones that you might use. So we'll say module.exports.isAuth equal to a middleware function. So there's the standard middleware parameters or arguments. And then we're going to do something in here to check whether the user is authenticated. And if they're not, we're going to return some sort of 401 unauthorized error. The second one we're going to do, module.exports.isAdmin. So currently we don't have an admin property on our user schema, but we could easily add that, and we could use this middleware to basically check whether the user is logged in and is an admin. So that can help you kind of protect routes that are for admins only versus regular users. We'll get to that in a second, but first let's get this one done. So all we're going to do is use that request.isAuthenticated method that is attached from the Passport middleware. So we'll say if request.isAuthenticated, then we're going to just say next and pass it on to the next middleware in the chain. If the user is not authenticated, we'll just return a 401 unauthorized error. So we'll just say res.status401.json, and we'll just put in a message that says you are not authorized to view this resource. All right, so that's pretty simple. So if they're authenticated, if they're logged in, we're going to just pass it on to the next middleware in the chain. If not, we're going to just stop it right there and return an unauthorized error. All right, so let's test this out. So we have the isAuth middleware. If we come to our route, let's do this. Let's kind of refactor this. So in our protected route, we're going to return res.send you made it to the route. So something to indicate to us that we successfully made it into the route, and within this route we could do whatever we want. We could return some sort of data. And to do this, we will just pass in isAuth as the middleware right there. And of course we need to import this at the top of this file. So we will say isAuth equals require auth middleware dot is auth. All right, so we've got this set up, and now if we try to visit the protected route, we should hopefully see you made it to the route. So let's try that. Go to Google Chrome, and we're already at our protected route. So oh, it looks like we are not authenticated right now because we had logged out. So let's log in really quick. So we are logged in, and when we click go to protected route, we should see that message that we just put there. It said you made it to the route, so our middleware is working. Now let's visit the logout route so that we can log ourselves out and then see if that other status is going to work. So now we went to the logout route and we were redirected to the protected route. I'm not exactly sure how that worked, but we got the error message that we were expecting, and if we were using, a front end, we could kind of process this error in a clean manner and give a friendly message to the user. So we've got our middleware working, and now all we have to do is pass in this short variable before any route that we want to protect. So the next thing is just kind of an added bonus. It's not necessary for all applications, but it's something that kind of just stretches your creativity a little bit. It gets you thinking outside of the box, and we're not just constrained by some framework that tells us that we need to do it this way. So in order to implement the isAdmin, we are going to come to the database and add one more thing to this user schema. So we're going to add an admin property, which is going to be a Boolean, and we'll save that. And then we need to actually register a new user so that they have this admin property. And we'll just by default put this new user as an admin. Let's see where that happens is going to be in the register route. Where are we? Okay, so right here is where we're going to do this. Currently, we're just passing in this data, but I'm just going to hard code in the admin property, and we're going to say true. So save that. We will come back to the browser, and we need to go to the register route. So let's go to register. Let me get rid of this, and I'm going to say Zach2, and we'll do the same password, 123, just so I don't forget it. Submit. We have put this user in the database. Let's go ahead and check that just really quickly to make sure. So we'll come to the Mongo shell, db.users.find. Now we have 2 users in the database. Let's kind of extend this. And the second user, Zach2, has an admin property of true. So Zach, the original Zach, is not an admin because we haven't added that property. The second one is an admin. So the first user should be able to visit an admin route while the second should not. So let's test that out really quickly. We need to make a route that will actually test it. So let's come down to protected route, just copy that, and instead of protected we'll say admin route. So the first thing we want to check is the isAuth. We kind of have some freedom how we want to do this. I'm going to go ahead and simplify things and just say isAdmin so we don't have to repeat it. So we could do isAuth and then isAdmin, and in this middleware all we have to do is check whether that property exists. But I'm going to go ahead and simplify that. You'll see what I mean in a second. So we'll say isAdmin. We need to import that here at the top. So I know this is not really good coding practice. We could refactor this a little bit, but we'll do it just for the sake of time. So we've put the isAdmin middleware in there. We've included it in the admin route, and we'll say you made it to the admin route if they successfully make it through that middleware gate. So now we come back to the auth middleware, and let's just copy the same exact thing, except this time we're going to say if request.isAuthenticated and request.user.admin. Since this is a Boolean property, we can just say this. So now we have 2 requirements to get through this authentication middleware. And then we have the same exact logic here. Maybe we'll change the message to say you are not authorized to view this resource because you are not an admin. Alright, so we've got this set up, and I think we should be able to visit the route that we just created. So admin route, let's just manually type that into here. And since we haven't, I don't think we've logged in with anyone yet. So let's log in with the first user. So this one should not be an admin. And we'll go to the admin route. And it'll say you are not authorized to view this because you're not an admin, as we would expect. Now let's log this user out by just going to log out. And then let's go to log in. We're going to log in that second user that does have admin privileges. Oh, looks like we had some sort of login failure. Maybe I just typed it in wrong. Oh, it was because I put the wrong username in. So it's not Zach1, it is Zach2. And 1, 2, 3. All right, we are successfully logged in. Let's go to the admin route, and this time we should get a success message. You made it to the admin route. So we've covered a good amount here, but hopefully this kind of opens up your creativity into understanding how the Passport local strategy works, how we can use it to creatively authenticate and allow access to different resources based on whether a user is logged in or logged out, based on whether a user has admin credentials, and you could even go through some more complex logic if you wanted to by creating different types of middlewares. I know it seems like we've already run a marathon just trying to get the Passport local strategy implemented, but again, user authentication is not an easy subject. I think we kind of treat it as an easier subject because it's like, okay, there's only a few moving parts here, it seems like on the surface, but once you get into the implementation, there are so many different things that you have to understand in order to debug and have a solid grasp around user authentication. I want to take a minute to say congrats. There's been a lot of content so far, and you have finally implemented your first official, user authentication scheme where you actually know what's going on behind the scenes. You can walk away from this tutorial right now if you want to, but there is a second part to all of this, which is the JWT-based authentication that I think is super, super important to know. And it's probably one of the more popular ways to do it, as I mentioned in the first, few minutes of this video. But as we saw with the Passport local strategy having all of these prerequisites, we also have some prerequisites for implementing a JWT authentication strategy. In this section, we're going to be tackling one of those prerequisites, which is public key cryptography. Now, I will make the disclaimer that to implement the Passport JWT strategy, or a JWT strategy in general, you don't need public key cryptography. In reality, you could very well just use a symmetric cryptography scheme, which is basically where you just make a long secret string and store that in an environment variable, and then use that to, authenticate through JWT. Now, I chose public key cryptography over something like, symmetric secrets because of a couple reasons. Number one, I think it's really cool. Public key or asymmetric cryptography is a really fascinating subject, and it's also kind of the basis of Bitcoin in a lot of those cryptocurrency systems. So not only are you getting an education on user authentication, but you're getting a basic education on how cryptocurrencies work as well. And the second reason is this is arguably more robust of a solution than a basic secret key. But in all reality, if you're still watching this course, then you're probably the type of person that would be interested in these extra little details. So let's go ahead and dive into a basic introduction to public key cryptography. This is a widespread topic. Public key cryptography and cryptography in general can be used for several different things, whether you're talking about user authentication, cryptocurrency, or even just secure transport over HTTPS. So I'm going to, in this video, be talking about what is public key cryptography and how does it work from both a conceptual and practical level. So we're going to walk through the basics of, conceptually how it works, but we're also going to look at some code and see it in action. Before I get into what public key cryptography is, we need to distinguish between two terms. So that would be asymmetric and symmetric cryptography. So public key cryptography, what you see on the screen, is a form of asymmetric cryptography because you have a public and a private key associated with it. Now, a more basic form, in what is used for TLS or Transport Secure Layer or whatever, I think that's what it is. Otherwise, the protocol that we use to transport data securely over an insecure internet channel, that is going to be symmetric cryptography and is identified by a single key. So a great way to think about this is maybe in a classroom setting. So say you're sitting in a classroom and you want to pass a secure note to one of your friends across the room, but you want to make sure that if the teacher intercepts that message, they can't read it. So what you would do is before class, you're going to connect with your friend or friends that will be basically interchanging notes, and you need to come up with a secret key. So you might just come up with a real simple secret key, and that key is going to be, okay, we're going to take every letter in the message and we're going to increment it by 2. So an A becomes a C. And then to decrypt it, you just have to take that C and bring it down 2 letters to be an A. So now that the people that are interchanging messages know what the secret key or the cipher algorithm is, they can easily read what the teacher thinks is gibberish when the notes are passed. So to encrypt the data, one student is going to basically, write something down, write the message that they want, and then they're going to transpose it using the cipher algorithm. So once again, an A becomes a C, a B becomes a D, and so forth. Then they'll have someone, walk that note across the class or pass it from desk to desk, and we'll say that the teacher intercepts it. The teacher cannot figure out what the note says, it just looks like gibberish, but the student on the other end could have decrypted that message by using that secret cipher. So that is what we call symmetric cryptography, and obviously we need to protect that secret. Now this is again used in transporting messages over the internet. It's also used a lot in web application development. You'll commonly see something called a secret key, and that is what you'll be using to encrypt some sort of data. Now on the other side of things, we have public key or asymmetric cryptography, which is a little bit more complicated and involves a private and a public key pair. So these private and public key pairs are mathematically linked, as we'll see a little bit later in this video, but the basic gist of it is if you have a public key, you can give this to anyone as long as you keep the private key secret, and then we can do 2 things with that public-private key pair. The first use case is going to be exactly what we just talked about with encrypting some sort of data. So you might think of this, the way that I like to think of it is a padlock and a key. So basically, this is kind of a contrived example, but basically think about maybe we're sitting in that same classroom and we have some sort of lockbox. And so one student is going to write a note which is just going to be in plain text, and they're going to put the note in the lockbox. So what they'll do now is they will close the lockbox and lock it with a padlock. So that padlock before class was actually given to this student by another student who actually owns the key to the padlock. So just to level set here, the student that's writing the message has the public key of the other student who will eventually receive that message and decrypt it with the private key that corresponds to that public key. So in other words, student writes the message, puts it in the box, locks it with the other student's public key, then we send the box across the room. We'll say the teacher intercepts it, tries to open it, but of course they don't have the private key that corresponds to that padlock or just the physical key that will unlock it. So they can't unlock it, can't see the message. But if it gets to the student who does have that private key, they can just unlock the padlock, open the box, and see the message. So that is your first use case. Now the second use case is a little more complicated, and we're not going to be able to understand it in the form of the classroom setting. We're going to have to get into a little bit more complicated math. But that second use case is called a digital signature or identity verification. And this comes in handy when we're talking about user authentication and is pretty much the entire reason for me making this video. So again, if you're following along the Passport.js user authentication series, what you're going to want to really focus on in this video is that second use case, or identity verification. As you'll see, to use these two use cases, all we're going to do is change which key we are encrypting and decrypting with. So to encrypt some sort of data but not protect an identity, we're going to encrypt with the public key and decrypt with the private key, as with the padlock and key in the classroom. Now, the second use case, we're just going to flip that. We're going to encrypt with the private key and decrypt with the public key. Now, in order to understand this, we have to understand what a trapdoor function is. And this comes in several different forms, but in the case of public key cryptography or asymmetric cryptography, we're talking about elliptic curve multiplication. We'll get to that in 1 second, but first let's just generally understand what a trapdoor function is. So basically what a trapdoor function is a one-way function that takes some pretty big piece of data and compresses it into a deterministic small piece of data outcome. So in other words, we can have an infinitely large piece of data. We could have, let's say, something as simple as what you see on the screen right now, or we could have something as big as maybe an entire book. And what we can do is we can take that infinitely large or small data and put it through what we call a trapdoor function. In this case, we're using a SHA-256 hash function, and that will always create a deterministic outcome. So it's going to be the same length. I think it's, I don't remember off the top of my head exactly how many bytes this is, but it's a hexadecimal representation of the data on the left. So if we were to come to an online SHA-256 hash calculator, I've pasted in that exact value in JSON string form, and we get out this hash value. And so anytime we put this particular data into this SHA-256 hash function, we're going to get the same exact output every single time. So it is deterministic. You can try it for yourself. Now, we also have to know about this that we cannot go backwards. So from this data on the right, there's no possible way that we can derive what the original data was in the first place. Even though we know that we're using the SHA-256 hash function, we know that that's only one way. You can't go the other way. The last important thing to recognize about this is we have an infinite number space, essentially. Now, it's obviously not actually infinite, but there are so many different combinations that the SHA-256 hash function can produce that the chances of us having two different pieces of data that come to the same hash value is essentially impossible. Now, there's plenty of Stack Overflow questions on this, and you can read up on them on your own time, but basically the probability of this guarantees that we're always going to get a unique hash value. What we're interested in when it comes to public key cryptography or asymmetric cryptography is a one-way function or trapdoor function called elliptic curve multiplication. Now, it's not actually multiplication, it's a cryptographic function, and basically all we need to know about this is that it mathematically links the private and public key. So in other words, using the private key, we can derive the public key, but having the public key, we can never get back to that private key. So in other words, we can share the public key with anyone in the world, and they'll never be able to figure out what private key corresponds to that public key. This, again, is useful for those two use cases of either protecting some sort of data or verifying an identity. We'll see a little bit more how this works when we actually get into the code, but first let's kind of take a quick glance at how elliptic curve multiplication works. So on the right, you'll see the elliptic curve graph, which is useful to us because given any point on on this graph, we can take the tangent of that point and get to another point on the graph. So say we're right here on the graph. Well, this curve extends infinitely, so we can just take the tangent all the way up to that curve. So let's go to the next slide and first start out with what we call the generator point. Now, the generator point is an arbitrary random value or coordinate that we will always start with. Now, this point in many cases is going to be a fixed point that we use for a large private key, I guess you could say number space. So we always start with the same generator point, but then the variable in the equation is the private key, and we take that private key and we multiply the generator point by the value of the private key. So again, the private key is some infinitely, well, not infinitely, but it's some small or large value. And so we can, just like we can take g times 2 and g times 3, we can also do g times 10 trillion or whatever the total value of that private key is. Now you might ask, how are we going to multiply g? That doesn't make any sense. This is a graph, and how are we going to actually do multiplication? Well, the way that works in elliptic curve multiplication is by drawing tangents, as we talked about. So you start with the generator point and say that your private key's value is 2. Now, obviously, it's never going to be 2. It's going to be a much, much larger number, and we're going to do this process many more times. But essentially what's happening is we start with g, we draw the tangent to that point on the curve, which the tangent intersects this other point on the curve. Then from that other point, we say, okay, what is the opposite side of the curve? So we draw this completely vertical dotted line to get to this last point on the curve. And that is essentially the multiplication value of our operation. So g times 2 is going to equal this coordinate down here at the bottom. So you can see how this is kind of, it's not exactly the multiplication that we're used to, but essentially what is happening is we start with this arbitrary generator point, we multiply, or we go through this process however many times the public or the private key value is, and eventually we will reach a certain point on the elliptic curve, and that is going to represent our public key. Now, we cannot get back to the private key based on the public key coordinate, but what we can do is we can derive that the private key that maybe signed a message corresponds to the public key. So in other words, what you need to understand is that using the complex math that elliptic curve cryptography does, we can actually verify that a public key corresponds to a given private key mathematically without revealing the private key to the person trying to verify it. So in other words, we can decrypt a message using a public key. You'll see how this applies a little bit later in the video. Just to recap before we get into the actual code, if we want to do data encryption, we're going to encrypt with the public key and decrypt with the private key. If we want to do identity verification or a digital signature, we are going to take the message that we want to sign and we are going to essentially sign it with our private key, and then some random party, some receiver of the message is going to have somewhere the public key that corresponds to the private key, and using that public key, as we just talked about, we can use that elliptic curve algorithm to verify that yes, indeed, the person who signed it has the private key that corresponds to that public key. Okay, so let's take a look at the actual code that will create this private and public key pair. Now, there's of course command line utilities that you can use to do this, but I wanted to kind of write it out so that we can explain it and understand it a little bit better. Let's go to VS Code real quick and create a new file. We're just going to call this create keypair.js. We'll open up this file and I'm going to paste in some code that I already wrote. So let's walk through this code really quick. We're using the built-in Node.js crypto library and then the built-in Node.js file system so that we can output the keys in this directory. And you'll see what's happening is we have a single function that will generate a key pair. All it's doing is using the crypto library to generate the private and public key using that elliptic curve multiplication under the hood. And then we're going to write that private and public key to separate .pem files in the current directory. So you'll see that here's where the magic is actually happening, and then down here is where we're taking those values and writing them to the files. So you can see that we're using the RSA algorithm to generate the keys. That's a pretty standard algorithm to use. And then these, you can just go ahead and look at them on your own if you want to pause the video to see what they represent. But basically, this is all the math that we just talked about. And when we run this script by saying node create key pair, it's going to finish, and then you'll see on the left we have both a private key and a public key. And in other words, this private key is something that we want to keep to ourselves, not share with anyone, and the public key can be shared with absolutely anyone with full confidence that they will never be able to figure out what this private key is. Alright, now that we have our private and public key, let's go ahead and use that in both of those two use cases that we talked about earlier. So to do this, just remember we have the private key and public key saved in this current working directory. So I'm going to close them. I'm going to close the create key pair, and then I'm going to create a new file called encrypt.js. And in this new file, we're going to write an encryption formula where we take some sort of data and we encrypt the data and we protect that data. So I'll paste in the code. You're going to see we require the crypto library again, and then I've got a single function that's going to take a public key and a message as an argument. So again, if we want to protect data but not an identity, we encrypt with the public key and decrypt with the private key. So what this file is going to do is it's going to take the message that we give it, it's going to create a node buffer with UTF-8 formatting from that message, and then it's going to pass that buffer into the built-in public key encrypt function that the node crypto library provides us with. And then what we're going to do is we're going to export this function so that we can import it into another module. So now that we have this, we can save it and then create one more file called main.js where we're going to do a lot of the work. Let's go on ahead and open up main.js and copy in some code that I already wrote a little bit earlier. So again, we're using the file system, and then we're also importing this file right here that we just wrote. So by importing this, we have access to the encrypt with public key function. And so what we're going to do in the main file is we're going to first get access to the public key that we created and stored in that PEM file in the current working directory. So we just use the file system to do that, and then what we're going to do is create an encrypted message and store it in the encrypted message variable. So you'll see that we are going to use the function that we defined in this other module. we're going to pass in the public key that we got from the file system that we created earlier. And here is our super secret message that we don't want anyone to be able to decrypt over a public channel. So once we do that, we can basically console log the encrypted message as a string, and you'll see when I save and run this file that in the terminal you'll see some gibberish that we cannot decrypt. So node main.js, and of course we see a bunch of gibberish. This means absolutely nothing to us, and there's no chance that we figure out what this super secret message was based on this data. So in other words, this right here is what you're going to transport over any sort of insecure transport layer. So to decrypt this, we can do that with our private key. So let's take a moment to see how that works. We'll clear the terminal and create another file called decrypt.js. And when we open that up, we can paste in a similar function to the encrypt file. So we're going to require the node crypto library, define a single function where we decrypt with the private key, and then all this will take is our encrypted message and the private key, and then it'll use the built-in node crypto library private decrypt function. So we're going to export this function so that we can import it in another module, save it, and then we're going to use the main module to actually decrypt this. Okay, so you're going to have to use your imagination a little bit because we're both encrypting and decrypting in the same file, but hopefully this will make a little bit of sense. So at the top part of the file, we have encrypted our super secret message right here. At the bottom part, we are going to import our private key, and then we're going to use the decrypt function, and we're passing that encrypted message into the decrypt function. And finally, we'll take that decrypted message and convert it to a string and print it to the console. So what we should expect with this file now is that in the console we're going to get that gibberish message that is encrypted, and then finally we will have the decrypted message which should say super secret message. So let's run that real quick. We'll say, gotta come down to the terminal. We'll say node main.js, and we have a problem. So let's see what the problem is. Decrypt is not defined because I did not import it. So let me import that real quick. Now that we've imported it, we can use the function. Let's try one more time. So we got the gibberish up top, and then we finally got the decrypted message at the bottom. So that is just a basic way that you can understand how we use private and public key pairs to protect data over an insecure transport layer. In order to see how digital signatures work, we're going to have to add a few things to our encrypt and decrypt modules. Because remember, we are going to encrypt and decrypt with different keys based on which use case we want to use. So let me do in the encrypt function or module, I'm going to add another function called encrypt with private key. So we can encrypt with the public key in case of data protection, or we can encrypt with private key in case of a digital signature. So let's go ahead and export that from this module real quick. So encrypt with private key. So now we have a module called encrypt, which we can do both encryption with the private or the public key. Likewise, we need to do this in the decrypt module. So let me just highlight this whole part, paste it in. We've got an extra import here, and we've got our function decrypt with public key. So now that we have those components, we can see how a digital signature actually works. But mind you, a digital signature is a little bit different than protecting data. We're going to have to go through just a little bit extra work to do this. Because this is a little bit more complicated, I'm actually going to make separate files for the steps of the process. So with the digital signature, we have some sort of data that we want to put our signature on. So just think of it like a legal document. You have the document itself with the data, and you want to sign it. And you want to make sure that the receiver of that data is assured that both the data that was on the document has not been tampered with. We don't want someone intercepting it and changing some of the legal proceedings on that paper. And we also want to make sure that the person we think signed it actually did sign it. So that's step one. We need to sign the message. Step two is actually verifying it as I just described. So for step one, let me go ahead and close all of these files. You know what is in them. So we will create a sign message.js file. And in this file, let's go ahead and import some different modules. So let me walk you through what's actually happening here. Starting from the top, we have the Node crypto library, pretty familiar. We also have the file system, and then we have the encrypt and decrypt modules that we created ourselves. Now the last thing is this hash function. And this is a SHA-256 hash. We talked about this a little bit earlier, and it is a trapdoor function that takes a pretty much infinitely large or small piece of data, and you put that data through the hash function, and the output of that hash function is going to be every single time you do it, it's going to be the same exact value. And that value is going to be small enough that we can kind of transport to different places. It's always going to be 64 characters long, which each character is 4 bits, so you have 256 bit value that is always going to come out of that function, no matter how big or small the data you put into it. Finally, at the bottom, you'll see that I have a piece of data. This is going to be the data that we're going to sign. Now, you'll see that I've got my first and last name, and then in the social security number field, we're never going to put that because remember, this second use case of signing some sort of data does not protect the data itself. If someone intercepted this data on an insecure channel, they would be able to read everything that is contained in it. So we never want to put any sort of confidential information in data that we are digitally signing. Alright, so the first thing that we need to do is we need to take this data right here, since it's pretty large, and we need to compress it down into that SHA-256 hash. So to do that, deleted it. To do that, I'm going to paste in some code that I wrote earlier. And what this code is going to do is first store the JSON string value of this data right here. And it's going to store that in a variable. And what we're going to do is we're going to use that Node crypto library hash function, and we're going to hash the data that I just put in string form. Then we're going to convert that into hexadecimal format. And this is important because the format that we're passing values between function in is actually really important when we're using the crypto library. We are now ready to actually sign this data. So let's paste in some more code. First, we're going to get access to the private key that we created earlier. And second, we are going to store the signed message in a variable. We're going to use the encrypt with private key function that we created using the Node built-in crypto library. We're going to pass in the sender private key. So in this case, I am the sender of this data, and I own a private key that I'm going to sign this message with. So I will sign the data with my private key, and this data is going to be in the form of the hashed data. So we're not just going to sign this big data object, we're going to sign the hashed version of that data. Now the last thing that we have to do is kind of that extra step that I was talking about. So if you just sent this signed message to someone, they're not going to be able to do anything with it. Not only do we have to verify that nobody has tampered with our legal document, so to speak, we also need to verify that the person that says they signed it actually did sign it. To do that, we need to provide the receiver of this data with a few additional pieces of information. So those pieces of information is, number one, which hash function we used to hash the data. Number two, we have to actually give them the original data so that they can take the hash function, take the hash of it, and then they can eventually take the signature that we provide them with and match it up with that hash data to make sure that I actually signed the data in the first place. So let's go ahead and see what that looks like. We'll go ahead and create a final piece of data. So we'll say package of data to send, to be very explicit, and we'll paste in this data object. So we've got an algorithm. So this tells the receiver of data, I want you to use the SHA-256 algorithm, and what I want you to put in that algorithm is the original data that we created. So you'll see that the original data is my data, which is the original object of data that we will use. And then, of course, we have the signed and encrypted data, which we assign to the signed message right here. So with this information, a receiver of this data can verify using my public key that not only was the data not tampered with, but I also signed it. Last, let's go ahead and export this package of data. So module.exports.data, or let's just call it the same thing that we called it here. Package of data to send equals package of data to send. So we can access this from another file. To do this, we're going to create another file called verifyidentity.js. We'll open up that file and we'll put our imports in there. So we need the crypto library, we need that decrypt module that we had created on our own, and then we need to import the data that we just exported from that other module. So this is everything that we need to verify this message. Now we also need to bring in the public key of the sender. So this will be made publicly available, and we'll say that, I sent this data in the first place, but my friend Jim, whatever, is going to be verifying it. So Jim will need my public key to do this, which again, public key is public and anyone can see it. You can feel confident that they're never going to be able to figure out what the private key was. And one thing you'll notice that I required this in, but I need to grab the variable that we exported. So require this module and the variable. So our received data is equal to this object right here in the signed message file. Next, we need to actually take our own hash of the data that we were provided. So to do that, we know that we're using the SHA-256 hash, and so we can use that hash function to hash the original data. I'll paste this in here, and you'll see that our hash function is going to be the built-in node hash function, and it's going to be the algorithm that was in that data package. So I know this is a little confusing, but this line right here in the verify identity file is the same as this import right up here. So where we said create hash SHA-256, we're also creating a hash, and we're just using that algorithm that we received in the data package. Like I said, we also need the public key of the sender, so we'll go ahead and get that in the public key variable. The next step to doing this is we have to take that data that was signed and decrypt it. So let's think about what this is actually doing. I'm going to paste in the code, and we're going to use our decrypt module. We're going to pass in the public key right here. This is the public key of the sender. And then we're going to take the data that we received, and we're going to pass in the signed and encrypted data. So if we come over back to the signed message, let's figure out what this was. So our signed and encrypted data was our signed message, which basically, if we decrypt that message, what it's going to give us is the hash value that we derived from this original data. So what we're going to get in this variable right here, the decrypted message, is simply a hash value. So in order to verify that, we can then take our own hash of the data that was provided in this object right here. So this is the original data, and if we take a hash of that and compare it to the decrypted message here, they should match. And if they do match, we can know that not only was the data not tampered with, but it was also signed by the person who said that they signed it. One extra step we've got to do is we've got to turn that decrypted message into a string value to pass it into our function. That's just a formatting thing. Finally, we say we want to look at the hash of the original. So we're going to actually take the hash of the data that was passed to us in that data package, and then we're going to turn that into a hex value. To verify it, we'll just do a basic if-then statement. So we'll say if the hash of original hex, so basically our own, so this is the receiver of data, Jim, is doing this. He's taking a hash using the designated hash formula and just turning it into a hexadecimal value so that we are comparing apples to apples. And then we're taking the decrypted message hex, which is basically what came with that, is what we decrypted, in comparing them. So if it is the same, then we're going to say success, the data has not been tampered with, and the sender is valid. So let's see if this works. Let's go down to our console and run node verify identity. And you'll see that it says success, data hasn't been tampered with, we have the right sender. So hopefully that makes sense. That is the second use case of public key or asymmetric cryptography, and is called a digital signature. It's a very common way to verify data and identities, and you'll see if you are following the Passport.js series that this video is kind of associated with, you'll see exactly how that works when we actually are authenticating users. Now, just as a consolation for this video, what we just did over the last few minutes when we were signing and verifying a message is the same exact process that is used with JSON web tokens. So you might say, wait a second, there might be a better way to transport this package of data over the internet. And you are right, there is indeed a better way to do this. If we were to send this package of data, it's going to actually be a pretty large piece of data, and it's going to slow all of our web searches down, especially if we're using it for some sort of authentication. So naturally, the easier way to do this is to represent this piece of data in a much smaller form. Just like we took the original data and we took a hash of it to make it smaller and more transportable, we can also do that with the data package that is sent to the receiver of data and is used to verify the original data. Let's jump into the browser real quick. And what I have pulled up is JWT.io, which has a really simple JWT visualizer per se. Now, don't focus on what is going on here because I have a separate video on that, but just recognize the structure of what's going on. So on the left, this is our entire JWT token. And you can see that it is pretty short, and it would be very easy to transport over the internet in a quick and efficient manner. But if we decode this JWT, it has the same critical information that we saw when we were signing and verifying an identity in our code earlier. So first we have the algorithm, which is represented by this reg string. And so this will tell us exactly what SHA-256 hash algorithm that we have to use to decrypt the data. Then we also have a payload, which is represented by this purple string. And you can see, I guess I deleted something here, but you can see that it has all of the information that we would need to include in that payload of data. So this you could consider that legal document that we are signing. And then finally, at the bottom, you have the actual signature. And this signature is going to include, you'll see the public and private key here, but this is actually just going to be the signature that we wrote in the code earlier, and we can verify it with a public key. All right, now that you have a basic understanding of public key cryptography, we can move on to understanding what is a JSON Web Token. Now I could of course go through a basic example and just show you the pieces and all that stuff, but I want to take it even further. As I promised, this is, hopefully one of the most detailed user authentication courses that you've ever taken. And in that light, I want to actually derive and sign our own implementation of a JSON Web Token using some of the internal Node.js libraries. The questions that I'm going to answer in this video is first, what is a JSON Web Token? We will then go into answering the question of how do we derive a JSON Web Token, like what are the pieces of it and how would we actually create one using code? And then finally, I'll give you a little bit of context as to how it applies to user authentication among other use cases. We'll start the video off by looking at the JWT or JSON Web Token spec on the Internet Engineering Task Force. Let me switch to Google Chrome real quick. You'll see that they have a write-up on JWTs and the specification for using them. We'll come back to this in a minute to look at a few things, but this is a very well-established type of token per se, I guess you could call it a token, that we use to transport some sort of data on the web. Now, something a little bit more friendly that we can look at is a website called JWT.io. And right here, I am looking at the example JWT, and we're going to be able to visualize what is going on a lot easier. Once we kind of understand what the JWT is, we'll actually go into writing some code to kind of replicate this example right here. So to understand a JWT, it's pretty simple. There are three parts. You have the header, the payload, and the signature. Now, the header and the payload, pretty easy to understand. The signature, not so much, because there's actually multiple types of signatures that you can do, and therefore it adds a little bit of complexity. On top of that, a signature is a digital signature, and it has to do with public key cryptography or just symmetric cryptography, depending on which algorithm you're using. So it requires a little bit of background knowledge, which is why I recommended watching that video that I had created on public key cryptography before this one. Now, you'll see in the algorithm field up top, we can kind of scroll through all of the different choices that we have for writing a digital signature on a JWT. But in our case, since I had you watch the public key cryptography video, we're going to do the RS-256 algorithm, which is basically, as you'll learn more when we get into the code, is telling us two things. So number one, we're going to use RSA private and public keys, that standard. And then number two, we're going to use the SHA-256 hashing function to actually take a hash of the header and payload data. I know that's a mouthful. We haven't learned anything yet, so just hold on to that knowledge in the back of your head. We'll come back to it and understand it in a lot greater detail in a few minutes. Let's start out by getting a basic understanding of what a JSON Web Token is. So I mentioned that it was made of three parts. You have the header, the payload, and the signature. And these are highlighted on the page here in the different colors. And they are separated by a single period. So the first part in red is the header, then you have the pink part, which is the payload, and finally this turquoise part is the actual digital signature. Now, what you're looking at right here is base64 URL encoding. And I'm not going to get super into it, but just a few fun facts about base64 URL encoding. It's a encoding spec that basically aims to standardize character sets, and it's derived from the base64 encoding, which was originally created well before my time of learning to code. But from what I understand, the idea there was previously, before the UTF-8 standard, where we had standardized character sets, there was debates over whether there should be 4 bits or 5 bits or 7 bits or 8 bits within a single byte of data. And before that was standardized as 8 bits per byte, there was varying use cases, and different protocols and applications would use different number of bits in a byte. And so therefore you might have an application that actually cuts off the last 2 bits of data. So what base64 was aiming to do was basically add this thing called padding into the data. And so it makes it so that there's no chance that any of the data is going to get lost in transport. And then the base64 URL encoding is just one extra step, because there were some characters within the base64 encoding that are not exactly URL friendly or file name friendly. So converting base64 to base64 URL just makes it safe to transport over the internet. And we also know that this format in general is not going to lose any data, which is obviously very important when we're talking about user authentication, which is a very common use case for JWTs. I know that was a bit of a long-winded explanation of an encoding, not so interesting, but as we actually derive this JWT with code, you're going to see that we're kind of constantly having to shift between the different encodings, and it's going to become a little bit more important later. Alright, now that you know what you're looking at here on the left, let's talk a little more conceptually what we're seeing here on the right side. So on the right side, all we've done is we've taken these base64 URL encoded characters, and we've decoded them into JSON objects. And in the header, you'll see that we just have a couple things. We have an algorithm and a type. And this is pretty self-explanatory, but when you're transporting JSON web tokens over the web, it's not always the case that the receiver of the JSON web token is going to know, anything about the JSON web token to start with. So in the header, the sender of the JSON web token, or the issuer, is going to identify which algorithm they use to create the digital signature. And then, of course, we say that the type of token is a JWT, because there's actually other types of tokens that we can use here aside from just JSON web tokens. So we have again chosen the RS-256 algorithm, which says we're using public key cryptography for the digital signature along with the SHA-256 hashing function. And what we're going to do is, well, actually before I get into this, let's cover what the payload is, then we'll get into that signature. So the payload is basically going to be metadata about some entity. And in most cases, it's going to be about a user, because JWTs are commonly used for user authentication. So in this payload, you're not going to see any sort of credentials. If you see credentials in a JWT payload, then you know that the developer has done something wrong, because you should never ever put credentials or sensitive information in the payload. It's publicly available. Anyone could decode this JWT just using a simple base64 URL decoding algorithm. So what this data gives us is just general information about the user. So you'll see the sub or subject is going to tell us who the user is. In many cases, you'll see some sort of database ID put in here, so that when an application decodes a JWT, they see, okay, here's the sub, it is this ID, let me look up this ID in my user table and retrieve the full user object. So that's what the sub is. Name, obviously just the name. Admin, just another metadata property. And then IAT is issued at. So it gives you the timestamp of when the JWT was issued. Now we also have additional what they call claims. That's kind of the proper term for these pieces of data. We have additional claims that we can define. And if you go over to the specification for JWTs, you have all this information, but down here at the bottom, or somewhere in the middle, we have the registered claim names. So these are registered. It says the following claim names are registered in the IANA JSON Web Token Claims Registry established by section 10.1. So in other words, these are kind of the official claims that you'll be using, and if you wanted to issue JWTs that would be interpreted by various applications, you would want to use these standard claims so that everyone knows exactly what they mean. So let's just go through the most common ones, and then there's a few others at the bottom you can look through on your own. So first is the issuer claim. This is going to identify the issuer of the JWT. Now in our case, we probably don't need this because we are both issuing and verifying a JWT within the same application. But in many cases, for more complex architectures, you'll see a certificate authority who is actually the certificate authority acts as the third-party authority that is trusted to issue JWT tokens, and that is literally all they do. So we basically can establish a centralized authority that everyone trusts, and that centralized authority will sign the JWTs with their private key, and because they sign it with their private key, they'll say, okay, here's our public key, and anyone in the world can say, okay, I trust that institution, and I'm going to verify this JWT with their public key. If it matches, I know that this JWT was issued by a trusted authority. So that's kind of where you'll see the issuer claim. The subject claim we already covered. The audience claim is going to generally be the resource that will accept this JWT. So in other words, if the JWT is only intended to be used with a specific application, it would probably list some sort of URL or base URL that will identify which server the JWT is valid for. So in other words, if Google issued a JWT token, they might put in the audience claim www.google.com, and if the JWT is attempted, if you attempt to use the JWT in a different context other than google.com, it's going to be rejected. And then finally, we have the expiration claim, which basically tells you when or what point in time this JWT token is no longer valid. There are additional claims that you can put in here. We saw the IAT issued at claim, but you can also, and this is important, you can also make up your own claims. This by no means has to be standardized. You can put whatever metadata that you want in the payload. And last but not least, we have the signature at the bottom. We've already kind of touched on it. I talked a lot about how this actually works from a cryptography perspective in that video that I asked you to watch before this one. Again, link is in the description for that. But anyways, I think it would be helpful to go through kind of a conversation between the server and the client to understand how this JWT is working in real life. So I've put together a basic little representation of this, and what we have here is what I kind of perceive as the conversation that the server and the client would have if they could talk to each other, in human terms, of course. So the server, just think of this as any application. We're kind of removing the idea of certificate authorities from this basic equation. We're just going to assume that the server, we'll just say it's an Express.js application, is both issuing and verifying the JWT tokens. So we don't have that third-party certificate authority in this equation. So what's going to happen is our client, or just basically our user, someone sitting behind a computer who is visiting our application on the web, is going to go to the login page and say, hey server, I want to log in to your application. Here's my username and my password. Then the server gets that information in the form of a post request, and it's going to say, okay, let me check on that. I want to go through my verification algorithm and look you up in my database to make sure that you exist and you entered valid credentials. We'll assume that the user did. So the server says, okay, your credentials look great. I'm going to sign a JWT token or JWT with my private key that only I know about. So the server is the only entity that has any knowledge of that private key. They're going to sign it and send back the JWT in the response body. So then the client or the user, basically this doesn't actually have any user interaction. It's invisible to the actual person behind the computer, but the browser or the front-end application is going to receive the response and say, hey, thanks for the JWT. I'll keep this stored in my browser's local storage until maybe it expires. So then the client is going to, once they're logged in, they're going to want to do something. So maybe this client wants to go edit their profile. So they'll type in the URL of the profile, just say somesite.com. This is just an arbitrary value. And then they're going to need to attach that JWT token, or I keep saying JWT token, but it's JSON Web Token, to the HTTP header that's called the authorization header. And so in the authorization header is where that's going to be stored. The server is going to receive that JWT in the request body, and then we're going to say, okay, I just talked to you, we're familiar, but I still need to verify that JWT because I don't know if in the time that you chose to visit the profile, did someone tamper with it? So we're going to take the JWT, and now the server says, okay, I signed it with my private key, but now I'm going to take my public key that everyone knows about, but I don't care because it doesn't actually matter. I'm going to take that public key and verify the signature on that JWT. And the server says, okay, that signature is indeed valid. I know that you are actually you, and the claims made on the body of this JWT are valid. Let me go ahead and look you up in the database, load your user profile, and give you the information required to actually edit that user profile. So that is the basics of how a JWT works. I'm going to, in a few minutes, go through the code for deriving a JWT, but I will also mention, again, this video was intended to be kind of part of my Node.js, Passport.js video series, which the playlist is listed in the description below. If you wanted to know more about what we just talked about, how this actually works in practice written in code, say for an Angular application, go ahead and follow that series through the end. Use the Passport JWT authentication strategy, and you'll see exactly how this works in practice. But for now, we are going to jump into the code editor and actually see this process written out, how we issue a JWT and then how we verify that JWT just using the built-in Node.js crypto library. To start off with, we're going to go through this part where we issue a JWT. To keep it as simple as possible, I'm going to take the example off of JWT.io. So if you visit this, you should see the same thing. And I'm going to actually be showing you how we get to this JWT, how we actually issue this one, and then how we verify it using the public and private key. So you should be able to verify how this works by just coming to this site, and you can actually follow along with the Node.js crypto library. So I'm going to go ahead and just copy this entire token. Again, this is in base64 URL format or encoding. So I'm going to copy that, and then we're going to come into the code editor and paste it in here. So I first need to create a file. So let's just say issue jwt.js. And you can see that on the left here I've already pasted in the private and public key. Those came from that JWT.io website. Alright, so I've copied in the key right here. Let me just put this as a string and store it in some sort of variable. So we'll say const JWT equals that. So this is the exact JWT that we saw from that example website. Now, in order to properly do this, we need one npm library, and it's called base64 URL. So I've already installed it, but you'll come down here to your terminal and install base64 URL to follow along with this. So I'm going to go ahead and require that in real quick. So we'll say base64 URL. And now we can take this JWT right here and convert it into something that we can actually work with. We now need to split up this JWT into its parts, which, if you remember, is designated or delimited by this period. So we can do that using some simple JavaScript. So we'll say JWT parts equals JWT.split, and we'll specify that period. So now if we were to console.log the JWT parts, we should have an array of those three parts. So let me go ahead and try that real quick. And you can see that we have an array, and the array contains the three different pieces of that JWT token. Again, these are still in base64 URL encoding. Let's go ahead and split these into variables. So I've just written this code already. We basically say header in base64 URL format is going to be the first one. So in our array right here, we're just grabbing that piece, and then so on and so forth with the remaining two. Now what we have to do is we have to actually take this base64 URL format and convert it to something else. Now that we have this in pieces, we can decode this with the base64 URL decoder, the npm module we included up here, and we can see the actual JSON objects that these represent. So let me put those in variables real quick. So we have the decoded header, payload, and signature, and we're just using that base64 library and using the decode method, and we're passing in the base64 URL pieces. And then finally we can console.log those to the terminal, and you can see what they look like decoded. So let's go ahead and console.log those. So we're just taking these three variables here and logging them. Save the file. Let's give us some space in the terminal here, and let's run this again. So you're going to see The first part is the same thing that we saw on Google or in the browser at JWT.io, and the second part also. So these match perfectly as we would expect. And then we have a bunch of gibberish at the bottom, and the reason being is because we haven't actually decrypted the signature yet. So once we decrypt the signature, then it will be in a format that we can understand a little bit better. Now that you've seen this decoded, I'm going to actually comment all of this out for a second because we don't need this. We're going to actually derive this JWT from scratch. So commenting that out for a second, we'll just space it down to the bottom. And what we're going to do is actually create this from scratch by first creating the JavaScript objects that we want to put in the header and the payload. So you can see that these are the exact same header and payload objects that we printed in JSON format below. Now obviously these are in JavaScript format, so we will need to convert them into JSON format by using the JSON.stringify method. So let's do that right now. I pasted in the JSON.stringify method and stored these two objects as JSON strings in these two variables. The next thing that we have to do, because right now these are just in JSON format, we need to actually convert that JSON format into the base64 URL. So to do that, we'll use this base64 URL library, and we'll just put it through the basic function and convert it. So here we go, copy this in. I'm just copying code that I wrote before to speed things up. But anyways, we have new variables. Hopefully these are labeled appropriately for you. But we have a base64 URL header and payload. All we've done, and we actually need to change this a little bit. So we're going to just use our import here, base64 URL, and the basic function that comes with that library is just a function to convert any sort of object into the base64 URL format. So these two variables store the correct format for our header and our payload. Now we have to actually sign and issue the JWT. But first, let's go ahead and check this. We're just going to console log these two values to make sure that we have actually converted these original JavaScript objects correctly. So let's go ahead and clear the terminal, give it some space, and run this again. And you'll see these two values, which we can actually check from the commented out code. So here's our original JWT that we just took from the website and posted right in there. And you'll see that this first value matches the first value of there, and then the second one, if you wanted to go out there and confirm that, it also matches. So we've got what we need. Again, the last thing we have to do is actually take some sort of hash of these two pieces of data and then sign that hash and put that in the signature. In order to sign this, we need to import a few more libraries. So at the top, I've imported the built-in Node.js crypto library. And then from the crypto library, we can also implement the algorithm that we're using for this JWT. So this is going to allow us to sign the JWT using this specific algorithm. And then we need the file system from the Node.js framework so that we can access the private and public key that we have saved in this current directory. Now that we have our imports, let's come down here, get rid of these console logs, and we're going to create the signature. So the first step is to use this signature function, and we want to write some sort of data into it. So right here, we're just passing in the header and the payload separated by this period, and this is going to be the data that is actually hashed using the SHA-256 hashing function. This is all kind of done within this Node crypto library, but we're going to hash this data and then we're going to sign the hash. So we've loaded the data in here. The last thing that we have to do is load our private key, which we're going to be signing it with, and then use the signature function sign method to actually sign the JWT. Here's the code to do that. Copy it in. First, we need to load our private key. That's literally just loading this private key PEM file. And I actually need to change the name for this to work correctly. So private key.pem. And it's important to put this in UTF-8 encoding. And then we are going to convert. This is kind of an important part. We are going to sign this data, which is going to give us a base 64 encoded signature. So then to actually derive the JWT, we're going to have to convert base 64 to base 64 URL. We can do that with this imported library right up here. So I'll show you the code for that. Here's the code that we use to do that. So we just basically take the signature that we got from the Node crypto library and we convert it from base 64 to base 64 URL. So now the signature should be in the same exact format that we were expecting earlier. Let's go ahead and verify that real quick. So signature base 64 URL. We'll print that out really quickly. And you're going to see this value right here. Let's go ahead and just verify it real quick. So here again is our JWT. We need to come all the way out to the last piece of it. And here we go. There's the last piece. And you can see that the first couple letters are matching up. And if you were to go through all of it, it's going to match to the character. So right there, we from scratch created a JWT token using the Node.js crypto library. Now, there is an easier way to do this, and I will show you that in a few minutes, but first we need to verify this JWT that we just issued. Since we already have a lot of the basics set up, we're just going to uncomment some of this code to verify the signature. So let me just make a comment for this first part. Probably should have just named this file JWT because we're doing both the issuance and the verification in the same file. So here is the issuance part right here, and then end of issuance, and then here is the verification, and we will go ahead and implement this now. So when we verify a JWT, we are basically receiving the JWT in the base 64 URL format. In this case, we just are going to use this one right here, the one that we just created, because we know that it's exactly the same as that example online. So to get the JWT parts, we're going to uncomment that. We will uncomment this part. We don't need any of these things right here. And I think we're set. So now we can actually verify this JWT. To do this, we'll actually have to just create one more line in the imports, and this is going to be the verify function from using the same exact algorithm. So we've got the issue or the create JWT function, and then the create verify or the verification function. As the verifier of this JWT, we have received the entire JWT right here. We've split it into parts, and now we have to actually do something with those parts. So the first thing we'll do is we'll take the header and the payload, and just like the signer of the issuer of the JWT did, we're going to take the header and the payload and append them together, separated or delimited by the period. And since the Node.js crypto library only accepts base 64 encoding, we need to take the base 64 URL signature and convert it using the base 64 URL npm module to base 64. So now that we have that, we can finally, I guess, decrypt the signature. So we're going to take our public key that corresponds to the issuer's private key, and we're going to decrypt the signature. So the first thing we need to do is actually get the private or the public key in here. So I'm going to just copy this line, and use that. We'll say public key, and we just need public key.pem. So now that we've imported our public key that we're verifying with, we are finally ready to verify this JWT. So let's copy this in. The signature is valid variable is basically going to run the Node.js crypto library verify function that we imported right here. So verify function dot verify, we're going to pass in the public key that we imported from the file system. We're going to pass in the JWT signature base64 format, and then the most important part, this will really trip you up. It took me honestly hours to actually get this to work because I had not included the base64 format in the verify function. So that's really important, and once you've done that, we should console.log the signature is valid, and I think it returns a Boolean whether it's valid or not. So let's go ahead and try that really quickly. Node issue, well, it's not really issue JWT, but bear with me. We get first the signature that we were console logging right up here, and then the signature is valid variable returns true. So we have successfully verified this JWT, and essentially we've gone through the whole process. So we created the JWT from scratch, and then we verified it from scratch. Now, if you wanted, you could use all the code that we just used in this example for your web applications to sign and verify JWT tokens. But like I said earlier, there is an easier way to do this, and that easier way is using the JSON Web Token NPM library. And what this library is basically an abstraction of the Node.js crypto library, and it gives you a little bit more options, because in this example we were just using the RSA 256 algorithm, and we didn't even get into, okay, what if we use a different JWT algorithm? So the JSON Web Token library is going to give you a lot of flexibility, and it also kind of abstracts away all of the things, all of these, when we have to convert from base64 URL to base64, you don't have to worry about doing that in this library. So this would be the library that I would recommend using in any sort of web application where you're issuing and verifying JWTs. And in the next few minutes, I will show you exactly how to use it. To save us a little bit of time, I've just copied in my implementation of the JSON Web Token library if we wanted to accomplish the same exact things that we did with the Node crypto library. Now, obviously, since this is abstracted a little bit, you're not going to get to see the little bits and pieces that are happening, and you don't get to truly understand what is happening with the JWT, but it does make your life a lot easier when you're actually coding. So let me explain to you what's going on here. The first thing you'll notice is I imported the JSON Web Token library. I already installed it with npm install JSON Web Token. So that is what that import represents. We use the file system, the Node.js file system, to grab the public key and the private key that we were using earlier. So again, this is the public key and private key from that example on JWT.io. And then you'll notice this payload object is very similar. We've seen it before because it's the exact same payload object. But you might notice that you don't see the header. And the reason being is that is one of the things that this library abstracts away. All we have to do is provide the algorithm, and the library creates the header on its own. So you'll see in this next line we have a variable called the signed JWT, which is a product of the JSON Web Token library sign method, where all we have to do is pass in the payload object in JavaScript form, so we don't have to do any of that JSON.stringify stuff and then convert it to base64 URL. None of that. We can just pass in a JavaScript object, Then, of course, we pass in the private key that we want to actually sign it with. As we know, that's how JWTs work. And then finally, in the options object, we just have to give it the algorithm that we want to use. And based on this algorithm, the JSON Web Token library is going to figure out what the header needs to be. So it will then combine that header and the payload, just as we did with the Node Crypto library. It's going to sign it with, I actually think they use the Node Crypto library underneath the surface, so they pretty much do exactly what we did earlier to sign this. And then to verify it, again, just one simple line of code or a couple simple lines of code. We just use the JSON Web Token verify method. We pass in the signed JWT, or this basically, it's going to be received in the authorization HTTP header for a web application. So we take that JWT, pass it into the verify function. We use the public key that corresponds to the signer's private key. In this case, since we're doing the signing or the issuance and the verification, it's just these two, this key pair. And then again, we have to pass in the algorithms that it will accept. In this case, RS-256. And then we have a callback function. In the callback function, if there's an error, we know that the verification has gone wrong, and either we have the wrong public key to verify this JWT with, or the JWT was tampered with, and we don't want to use it. So let's go ahead and just verify that this works really quick so you can see it in action. I will console.log the signed JWT value. So let's just do that first really quickly. And you'll see this value right here, which if you were to match with the value online, it's going to be the same exact thing. So you can do that on your own time, but just trust me, that is the same exact JWT. And then here we can go into the callback function, and let's say console.log error, and we should expect that we don't see any error whatsoever because we verified this successfully. So we get null as the error as expected, and then we can also console.log the payload, which is the second argument that it returns, and you should get the same payload that we had defined right up here, except this was when we issued it and then this is when we signed it. So you can see how this might work in an actual application. You might have a post route that is going to verify credentials, and then it will sign and return a JWT in the response. And then you might have another couple routes that are like authenticated routes, and you might have some sort of middleware like Passport.js that is going to, underneath the hood, use this JWT.verify method and use the public key to verify the JWTs that are being passed through the authorization headers. A couple hours later, and we're finally ready for our second form of user authentication, which is the Passport JWT strategy. I think this next section is going to be really rewarding for you because we're about to take all of those prerequisite lessons that we went through, whether that be the Express middleware overview or the basics of cryptography, and we're going to combine those together and put it into our user authentication strategy. This one's going to be fun, so let's jump in. The first part of this series, we went through the Passport local strategy, and in doing so, we talked a lot about the inner workings of the Passport framework. And in this second part, since it's a little bit more advanced, I'm going to be skipping over those details. So if you find yourself lost, for example, in the process of generating and validating a username and password in a database, or maybe the verify callback for the Passport middleware, I would suggest going back to the first part of this series and specifically just watching the configuration video for the Passport local strategy. Now, before we start to code, I want to go through the options that we have here when implementing a JWT authentication strategy. So we're working with the Passport JWT middleware strategy, but we don't necessarily need to. And this is going to be the most confusing part for someone looking for a solution on the internet, because there are all sorts of ways that you can actually implement a JWT strategy in your application. And because of that, you'll have people who understand JSON Web Tokens pretty well, and they'll have their own custom strategy working, but they won't explain kind of how they got to that strategy. And it leaves you, the reader of the tutorial, just thinking to yourself, well, what's the actual correct way to do this? And in this video, I've stuck with the Passport JWT middleware, not because it's 100% necessary, but because I think it's kind of grounded and it gives us a framework to start with, and then we can kind of customize on the fringes as we see fit. If we were trying to be very complex about this, and probably the reason you would do this is if you were maybe trying to write your own authentication framework, or you're building your own authentication server, or something that you have to do that's extremely custom. The most complex thing that you could do is you'd use the Node.js crypto library and then pair that with your own express middleware that work together to authenticate your users. Now, I have no interest in doing this because there's a lot of code that you'd have to write to do that. But given the fact that we actually went through the process of issuing and verifying JWTs with the Node.js crypto library, you already have a pretty good head start if you did choose to use this. Now, the somewhat complex method for authenticating users via JWT would be to use something like the JSON Web Token NPM library, which is going to give you a little bit more abstraction. You have a lot less things to think about when you're actually issuing and verifying the JWTs, but you're still left with writing your own custom middleware for your Express application. So that leads us to the least complex method, which is what we are going to do, and that is to use the JSON Web Token NPM library. So it's going to be really simple to issue and verify the JWTs, and then we'll use the already built framework, Passport.js, and then plug in the Passport JWT strategy into that framework, so we have our middleware written for us. But you don't need this. Like I said, there's a lot of different ways that you can do JWT authentication. The reason we're going to go with the Passport JWT strategy is because it kind of just takes care of some of the tedious things, like, say, error handling or extracting the token from the authorization HTTP header. Like, all of those things you have to write your own code for, which is also going to be error prone, and you've got to test it. So we would prefer to kind of offload that to a framework that's already been tested and used by a lot of different use cases. So that's kind of why we're starting with the Passport JWT strategy, but wanted to lay that out for you. The last thing that I want to go through before we get into this is the basic conceptual flow of how JWT authentication is going to work. Now, this slide right here assumes that you understand the issuance and verification process of a JWT, which again was in that prerequisite video in this playlist. But anyways, what happens is a user is going to log into a web app. So we'll assume that they're already registered, they're already stored in the database. Our application is going to go through the basic password verification process. I talked about that in the session-based authentication, or the Passport local video. But basically all we're doing is we're taking the username that the user is going to log in with. We look up that user in the database, and then in the database we have a salt and a hash stored for that user. Then we're going to use some of the Node.js crypto library methods to actually take the plain text password that the user just passed to us and compare it against the salt and the hash that were stored for that user record in the database. If the user has validated correctly based on our logic, then we are going to use, we'll say, the JSON Web Token NPM library to issue them a new JWT token. Now, this JWT token has information about that user as well as a signature from the server itself. So one of those pieces of information is probably going to be the database ID of the user. So then the user client, which is usually a browser, is going to store that JWT. So back up just a second. The server issues the JWT and sends it in the response body of the HTTP request. Then the user client receives that HTTP request and stores the JWT that it received there in local storage or maybe even a cookie. It doesn't exactly matter where you store it, it just has to be persistent storage in the browser. Then on every single HTTP request that requires some sort of authentication, so maybe you're trying to access a protected API, the user is going to, or the user client is going to attach that JWT in, most commonly, but not always, the authorization HTTP header. The important thing is that you put that JWT in the correct header that the server is expecting. And the authorization header is just the most common that you'll probably see. Then the server looks for that JWT in the authorization header because you've coded it to do so. And it's going to use the JSON Web Token library to verify the signature of the JWT. If the signature is verified, we know two things. We know that the JWT has not been tampered with. None of the data in it has been tampered with. We know that it also came from the person that we expected it to come from. So if the signature is valid, the server then will decode the JWT, which is in base64 URL encoding. So all we're doing is just taking that from base64 URL to JSON format. Then we will read the payload, which is going to have information about the user. So we're going to probably go for the payload.sub field. That's the most common place to find this information, and it's where we're going to implement it in this video. And we're going to grab from that field is going to be the database ID for the user. So then the server is going to take that ID, look up the user in the database, and then now it has the full user object. It can do whatever it wants with that user object. In our case, it's going to attach it to the express request object, and then we can use it within our routes. And then finally, once all that has happened, the user is going to have access to the resource that they requested, and our flow is complete. That's the process. If you ever find yourself confused as to what we're doing with the code later in this video and the next couple videos, I suggest that you kind of keep this, pause the video on this slide, take a screenshot of it, maybe even print it out so that you know exactly the pseudocode steps that we are going through. Okay, so the next thing that we'll do is come back to our code. And what I have open is a GitHub repository that you can download yourself. And how I've structured it is we have two branches on this repository. Let me see if I have it open in the browser. We can just visit it there. There we go. So here's the repository that we have. I just finished it up a few minutes ago. But basically we have two branches to work with. So the first branch that we have is going to be master. And this is what you're going to have as the default when you clone this. And it's going to give you a basic starter skeleton for implementing the JWT authentication strategy. As I talked about in other videos, my goal here is not to teach you how to write an Angular app. It's not to teach you how to write an Express app, and it's not to teach you how to use a database with Express. the goal here is to solely focus on the authentication piece. So what I've done in this template is I've done all the implementation for all of those pieces that I don't want to cover, and I've left blank the specific pieces that relate to the authentication. Alright, so when you clone this and you come back to whatever code editor that you're using, you'll go ahead and npm install in the base of the folder, and then you also, over here, I'm in the Angular folder, so right here, you'll go in the Angular folder and also type npm install. Once you've done that, then you'll go to the .env file and you're going to enter these 3 variables. Now, you don't necessarily have to do this, but I guess if you're using this as like kind of a starter, you'll eventually need to implement a production database string, but this is going to be entirely sufficient right here. And then you're also going to have to come over to this script right here, generate key pair. And we talked about this in the prerequisite video on public key cryptography, and this is the exact file that I used in that video, and all it's going to do is create an RSA public and private key pair, and then it's going to save it to the current directory. Now our Passport JWT strategy is going to use this public private key pair to issue and verify the JWTs. So you're going to need to generate this. The one thing that I'll note about running this file, if you run into an error trying to run this, then it's probably because your Node.js version is not great enough. I think there is some method here. I don't know which one exactly. It might have been the generate key pair sync from the crypto library, but it was only implemented in, I think it was version maybe 10 or something. You can go ahead and find that. We're in the master branch right here, but in the final branch you'll see exactly how to start the app, and it gives you the required Node.js version. I think it's like 10. Let's just verify this right now. So let's go skip over to the final branch, which has the final implementation of everything, and it's going to tell you that you need version 10.x or greater to do this script right here. Alright, so make sure that you have that set up, and then you're going to just say node generate key pair and press enter. And what this will do, I might as well just do this right now. So let's delete what I've got right here already, and then say node generate key pair, and you'll see in the left side here, it's going to pop up in a second. You should see the public and private key pair that I just created. Let's refresh it. There we go. So we have the private key and the public key, and you should be good there. And then the last thing that you need to know about the setup, I think, hold on one second. That was actually it. So that's all you need to do to set up. You'll also need to run the MongoDB database in the background. So go ahead and do that before you run the app. And then when we actually run this app, we're going to, it's not going to work here because I haven't implemented everything, but we're going to run node app.js in the root, and then ng serve in the Angular application, and then we're just going to visit the Angular application to run the app. But that Angular implementation is the last video in the series. If you're not interested in that, then that's totally fine. It's totally optional, but it's just a common thing to see JWT authentication in a single page application. They're pretty compatible, so that's why I decided to include that last video, that last optional video. Okay, so you should be set up completely with the repository. You've cloned it, you've done your setup steps. Now let's take a very quick look at the code. I'm going to purposely try to fly through this, and I'll assume that you're going to go through on your own and get yourself familiar with what is here already. But I definitely want to go through a few things here. So we'll start with the Express app, because that is kind of the required piece. Let's open up app.js, and you'll see that we already have kind of our skeleton app set up. So of course we have Express. We're going to import the cores module, and the reason being is because in the optional final video where we go through how to implement this with Angular, we're going to need to make HTTP requests from localhost 4200 to localhost 3000. So from the Angular app to the Express app. So you're going to need this cores piece in here. Path just going to give us access to the path that we want to save things in the file system, Node.js. And then we're requiring in Passport the .env configuration. I talked about this in a previous video, but basically gives us access to the environment variables stored in the .env file. And we access those with process.env.variable name. So that's how you will do that. Set up our basic Express app. We're going to import the configuration for the database, which is right here. Just scroll through here. It's basically saying if we're in production environment, connect to the production string. If not, connect to the development string, which is just running on localhost. And once it's connected, we should just get a little message that says it's connected. Pretty simple there. Alright, so then we require in our database models, which is one model, and it is the user. So let's open up that real quick. Same exact user schema that we used in the first part of this with the Passport local strategy, and we're just having a username, and then the hash and salt will represent the password in the database. Then we will require in the Passport configuration, which is where we're going to configure the Passport JWT strategy. Now, it's a little bit weird syntax, but basically in the Passport configuration, we are exporting a function that takes the Passport object. So we are importing the Passport library in app.js, and then we are going to pass this variable right here into the configuration function, which will then receive access to that, and then in the body of the function it will actually do the configuration on that object. So that's kind of how that's working. We'll come back to that quite a bit, so don't worry about it. Then we will initialize Passport. This is required for any Passport strategy. You always have to initialize it so that it runs every time that you make a route request. These are pretty simple, just body parser, middleware, except now Express has their own implementation, so we don't have to do the body parser middleware that you're used to seeing probably. So something like app.use bodyparser.json. We don't have to do that because Express has their own implementation now. Here's the cores we talked about. This line right here is going to allow you to kind of combine the Angular and Express apps. Since the Angular thing is optional, I'm not going to go through it too much, but it's going to basically, if we come over to Angular and type ng build, it's going to build all of the assets, all the static assets for that application into this public folder, and then Express is going to use that public folder as the static directory. So in other words, Express is going to use the Angular build as the front end for the application. Alright, so that's what that's doing. We're requiring in our routes, which should just be okay, so here's a basic route configuration. If you wanted to extend it easily, you could just add more route files and then add, you know, another line here that would say something like users. We'll say, I don't know, something like courses. Maybe you're building some sort of course module, and then you would have something similar to users right here where we have all of the user routes. So that's kind of how you would extend that. And then in the user routes, we just have a protected route, which is going to allow us to test whether we did the JWT authentication correctly. Then we have our standard login and register post routes, which is going to allow us to issue the JWT and kind of validate the JWT. And finally, we have app.listen, which will listen on localhost 3000. So that is the basic Express app that we're working with. And again, I would hope that you would go through this and get yourself a little bit more familiar. But if you've built a lot of Express apps in the past, this probably looks like a pretty familiar structure. Now, in the Angular app, I will go ahead and save that. We're not going to go through what's happening in the Angular app until you actually get to the video on Angular. So it kind of, if you're not wanting to watch that, we're not going to go through it and waste your time. With that, I think I've gone through everything that we need to get started with the Passport JWT user authentication strategy. And like the Passport local strategy that we did earlier in this series, it's going to follow a pretty similar structure. So just like we did in the Passport local, or pretty much any Passport strategy, we're going to need something called a verify callback. So in other words, when we're in our routes, so say we're in our login route and we pass in a passport.authenticate method, what that method is going to do is call the verify callback that we have defined in the Passport configuration. So if we open up config Passport.js, it's going to be defined right here. So whatever we define within these brackets is what is going to be called when we use the passport.authenticate method. As with any new package, let's go ahead and look at some of the documentation. So the documentation for Passport JWT, I have it pulled up right here. You could also go to strategies on the home page and click Passport JWT to find it. So the documentation, like most strategies, is not necessarily uniform. All these strategies are coded by different developers, so it's all based on how that developer is going to put it in there. So you can see here it's a little bit jumbled up, but it gives us most of what we need to know. The first thing that I'll draw your attention to is going to be right here. And you'll see that just like the Passport local strategy, the Passport middleware as like a framework is going to expect the same three responses. So if our callback returns some sort of error, whether it be a database error or an Express application error, we pass in the done callback with the error parameter as the first parameter, and then false for the user object. Then if we successfully authenticate the user, we say that there's no error, and here's the user object, which will eventually be attached to the Express request object. And then finally, if there is no error within our application, but there's also an invalid user, then we're going to say there's no error, but there's also no user. So these three responses to this verify callback is how Passport knows what to do. Alright, so now that we got that covered, let's look at some of the options that we're going to be dealing with when we're using the Passport JWT strategy. So as we know, we're going to call passport.use, and then we're going to pass in a new some sort of strategy. In this case, it's the JWT strategy, and then that strategy is usually going to take options first and then the verify callback. So those options here are going to be defined up here at the top, and I will note that most of these options are related to the JSON Web Token NPM library. So if we open that up, here's the JSON Web Token library. This is actually what the Passport JWT strategy is using to verify our JWT. So all of the options that you see here, so there's some examples. Here's the JWT.verify method. This is exactly what the Passport JWT middleware is using, and all this strategy is doing is passing in the token that it receives. It's going to pass in the secret or public key, so there's multiple ways that you can verify. We're going to be using the public key since we're using asymmetric cryptography. And then we have the options object, which is literally going to be just passed straight through to this method from the Passport middleware. So you'll see down here we have all the options that we can put in here: algorithms, complete, issuer, ignore expiration. All of these you'll also see, well, not all of them, but you'll see most of them listed here in the strategy documentation. Now, the way that we actually include these options is a little bit tricky, and I actually could not, based on this documentation, figure out how to get all of these options passed to the verify callback. So what I've done is just put together every single option that you could possibly ever need, and I've put it in a single options object. And then we'll kind of reduce to only the stuff that we need. Going back to our code, let me just paste in this like all-encompassing options object. And I might even leave this in the final implementation, just comment it out. But here is the full options object. If you were to pass in this, obviously you need to replace some of these things with valid values, but if you were to pass this in, it would be readable by the Passport JWT middleware. So you'll see at the bottom we have the JSON Web Token options, and this is where it gets a little confusing, because here are some of those JSON Web Token options that we saw in that libraries documentation, but there are also options from JSON Web Token that are passed up here. And if you were to pass these down in the JSON Web Token options, the Passport JWT middleware, as it's implemented, would not actually read them correctly. So it's really important that you put the options I have listed here exactly how you see them. If you see them in the JSON Web Token option, they need to stay there. So that is the entire all-encompassing option object, but we don't actually need that. I'll go ahead and put this in the final branch of this repository, but I'm going to delete it out for right now, and we're only going to work on what we need. The very first thing we'll do, as with any module, is import it. So we need the Passport JWT strategy, and we're going to extract the strategy off that, so that's going to be a class, and then this extract JWT class, which is basically a little subclass that is going to give you options as to how you extract the JWT from the HTTP header. If you look at the documentation online, you'll see that this is detailed at the bottom. So in the section extracting the JWT from the request, this just has to do with that process where the server needs to know how and where that JWT is stored in the request. Usually it's going to be in the authorization HTTP header, but it isn't always there. So this gives you some options as to where you can find this. So we're going to just be using from auth header as bearer token. This is probably one of the more common ways to do it, but you could also pass it into like a post request body field. You could put it in a URL query param, and if you were to do that, you would use these different methods from this class. You could also write your own extractor function. So I know I mentioned earlier that you could put the JWT in a cookie, and this right here just gives kind of that example. This is how we would grab it from a cookie, and so you can kind of have some freedom to implement whatever you would like. So our options object is going to be pretty simple. Just going to replace this right here. And this is what we're working with. So this is the options object that we're going to need to implement the JWT strategy. First is what we just talked about. The extract JWT class comes with different methods for finding that JWT and parsing it. So we're going to use the from auth header as bearer token. So in other words, it's going to expect that we have our JWT sitting like this. So here's our authorization header, and then we're going to say bearer, and then a single space, and then here is where our token is going to sit. So it expects this exact syntax, and if you were to maybe take the space out or just delete the bearer portion completely, it's not going to be able to read it correctly. You'll see how that works a little bit later. The next thing is the secret or key property. And you can either pass in a symmetric key, which would just be a secret that you stored in an environment variable. But for us, since we're using the RS-256 algorithm to issue and verify JWTs, we're going to pass in our public key that we generated with that script right here. And we're reading that from the file system. It says path to key ID RSA pub. And the reason that we're passing in the public rather than the private is because what we're configuring right here is the verify piece of the JWT. So if you remember, we have the issuance and then the verification. With a digital signature, we sign the issuance with the private key, and then we verify the identity with the public key. So that's why we're passing in the public key, because Passport is the verification step of this process. Then finally, we're just passing in the algorithms that it will accept, and we should be done with it. So that's our options object. Obviously, we didn't include half of the options that were available to us, but I just wanted you to know that those were available in case you were doing something a little bit different than me. Like I did with the Passport local strategy, I'm going to kind of deconstruct this configuration so that you're not just looking at a big blob of callback functions and options and all that stuff. So we're going to keep it as modular as possible here. The first thing that we do, we have our options object already configured, but we need to use the JWT strategy right here. So we're going to say const strategy equals new JWT strategy. All right. So that is going to take two arguments, one being the options object that we defined right here, and two being a callback function, which is going to, it's already telling us what it expects. So it's going to take a payload and a done callback. All right, so that is the basic implementation right here. And then we're going to actually configure it by saying passport.use strategy. So again, this passport object is being provided from app.js. Then we're taking that object, we're saying use, so similar to a middleware, and then we're passing in the strategy, which has the options configuration and the callback function, or the verify callback, that we are about to implement. Within the callback, as I mentioned with the Passport local strategy, the great thing about Passport, and also the confusing part, is you don't have a specific way that you're required to verify in authentication. And in our case, we can use whatever database we want, we can use whatever code logic we want to do. Now, since we're using MongoDB, we'll just use the find one method on the user model. So we've imported this from our database configuration. So we'll just say user.find1, and then we're going to pass in the ID. And where are we going to get this ID from? Well, if you remember from previously in this, I think it was in the first video, we talked about how the JWT payload, so the second part of a JWT, is going to have a subfield Well, in our case, it has a subfield, and in many cases, it has a subfield that will include some information or unique identifier about the user. In our case, when we implement the register and login functions, or the routes, we're going to issue a JWT, and we're going to place the MongoDB database ID in the subfield. So here's our payload. This is in JavaScript object form. So we can literally just say payload.sub. And that's going to pass in the ID that we need to look up our user in the database. We will then use promise syntax to grab the user, and then we will catch any errors that happen. And if you remember, we need to pass in the error to the done callback if we, and no user if there's an error within this operation. So the last thing we need to do is something in this area where we have access to the user that we just looked up. Now, if you were watching the Passport local strategy, you'll probably remember that in this area we were doing all sorts of stuff. We were verifying, using a crypto function. We were verifying the username and password. Well, in this JWT strategy, it is much, much simpler. We've already validated this JWT. So this strategy has already gone through the process of using the JSON Web Token library to verify the JWT that it's received. So at this point, when we're sitting right here, we already know that our JWT is valid. So all we have to do is check if we found a user in the database, and if we did, we need to return it to Passport so that it can attach that to the request object. So we'll just say if there's a user, we will return done, and there's no error, but there is a user. Otherwise, we're going to return done, and we're going to say no error and no user. Excuse me, this is not null. This is going to expect false. So Passport expects to see either a user object or false. So that is the implementation that we need to do for this verify callback. It seems like nothing really is happening, but behind the scenes, the Passport JWT strategy is taking these options, it's grabbing that JWT from the authorization header, it's validating that JWT with the JSON Web Token library. Then once it's validated it, it passes the payload object right here. Then we grab the ID of the user from the payload sub object, look it up in the database, return it to Passport, and then Passport attaches it to the request.user object within the Express framework. So that is all that we needed to do to implement Passport JWT. Now I would try this out in the browser and see if it's working so far, but the problem is we haven't issued any JWTs. So we could go generate a JWT or grab an example from online and see if it would work with this, but it never will because we have generated exactly 0 JWTs using the private key that we generated in this repository. So in other words, when Passport JWT strategy tries to verify the JWT we've included in the authorization header, it's going to reject absolutely everything because there is no JWT in existence right now that corresponds to this private key. So when we verify it with the public key, it's just going to reject it. So what we need to do is write some logic in our login route so that every time a user logs in, we're going to issue them a new JWT that is signed with the private key that we are using from this server. Then the Passport JWT middleware will use the public key that resides on this server and will successfully verify these newly issued JWTs. So to do this, we need to come to the routes. So we're in the routes users.js file. And the first thing that we'll need to do is the register function. So if a user is going to come to our application, they obviously need to first register. And basically what's going to happen in both of these routes is we're going to issue a JWT regardless. So the way that this flow is going to work is if a user comes to our application and has never been there before and registers, they're just going to provide their username and password. Then we're going to store that new user in the database and issue them a new JWT. And then we're just going to consider them logged in for as long as that JWT is valid. And then the login is also going to issue a new JWT, but it's just going to look up the existing user in the database and validate the username and password that user put in there when they registered. If you watch the Passport local strategy videos, you're going to be very familiar with what I'm about to paste in. So what we're doing here in the register function is we are taking the plain text password that the user has provided us with, and we're creating a salt and a hash based on that plain text password. We're just using some crypto utils. So if we go in lib, you'll notice that these two functions, valid password and gen password, are going to be the same exact generation and validation functions that we used with the Passport local strategy. And so you might ask yourself for a second, well, wait a second, isn't this a JWT strategy? Like, why are we working with like username and passwords and all that kind of stuff? Well, you have to remember that the JWT is simply a result of a successful user authentication with a username and password. So whether you're using the Passport local or Passport JWT authentication, you're always going to need to know how to store a password in the database and then verify it out of the database. I'm not going to go through that. If you wanted to really understand how this works, I do have a slide on that. Let me just pull it up really quickly. So here is the basic password validation process. Since I talked about it in the Passport local strategy a lot, just go watch that video if this doesn't make sense. Otherwise, just read through this really quickly. All right, so that's basically what's happening with the password generation and verification. And in the register function, we're doing part one of that. So we're going to create the salt and the hash and store those in the user record in the database. Then we'll save the user in the database and just return a success message as well as the user object. Now, I also mentioned that we're going to be issuing a JWT here, which we will do in 1 second, but I want to first look at the function that is creating that JWT. So we go to the bottom of the utils, and you see that we have exported this issue JWT function, which is defined here. And since the Passport JWT middleware is using the JSON Web Token NPM library, we might as well use the same library to issue the JWT. So what we're doing is we're taking in the user object that we have in the database. We are going to take the ID of that user in the database, and we are going to assign it to a variable here. We are going to say that we want this JWT to expire in 1 day. Usually you'd probably do this like 2 weeks or something, but we're just going to do 1 day for now. And then the payload of this JWT is going to be defined as the sub property will have the ID, as we talked about when we were configuring the Passport object. And then the issued at will just be whatever timestamp is right now. Then we will sign the token, and we're going to do that using the .sign method of JSON Web Token library. We're going to sign it with the private key. We imported this up here at the top. So here's the private key that we imported. And that private key corresponds to the public key that we're going to verify later with. Then we're going to pass in the expires in value and the algorithm that we plan to eventually verify it with and that we will sign it with. So once we've signed the token, we will return a token which has the bearer string at the beginning, and then the signed token, and then the expires in property. So we have this function that's going to issue a new JWT, signing it with the private key living on the server. And then we're going to come back to our users routes. And then in the success message, we're going to attach a token and then a expires in property. And to do this, we just need to, well, actually, we're going to want to do this down here, because when we initially create the user, we don't have the ID that was stored in the database yet. So we need to come down here in the callback to get that ID. So we'll say the ID is equal to user.id, and then we are going to issue this JWT. So I think I've already included the utils library. So we've got the utils library up here. So we're going to say the JWT is equal to utils.issue JWT. Then we're going to pass in the user. And actually, I don't know why I did this right here. The function itself is going to grab that ID off of the user object. So all we have to do is pass in the user. And then if you remember, it returns us an object with a token and expires property. So we're just going to grab the JWT.token and JWT.expires. And there we go, we have a successful response. And once we have saved this user in the database after registering, the front end client will get this message right here. So let's do that really quickly. Let's run this, make sure that we don't have any errors going on. Looks like the database connected okay. And I'm going to open up Postman, which is just an HTTP request application. It's got a lot of other stuff. I should probably be giving it more credit than that. But let's go to register. I've already got the post request set up. And in the body, we're just going to require, I think it was just a username and password. So we'll say the username will be Zach. We'll say Zach JWT, just so that we can distinguish from the Passport local strategy I was doing in a previous video. Then the password will be just 123, my default debugging password here. So I think that's all that we need for this request. Let me just check that really quick. Okay, so this is all we need. We should be able to run this and hopefully it works. Let's see what we got for the response. Looks like we had some issues, so let's go back and see what's going on. Oh, of course. We have the wrong route that we're using. I just said register. It's actually going to be, I think, users/register, or even maybe even API/users. We'll find that out real quick. Come back to the code. Let's look at our index.js. Okay, so we're gonna, so it's the /users route is what we're gonna need. So come back to Postman, get rid of this API, we didn't include that. Now we should be able to send it and we get a successful response. So here's our response, success is true. Here's the user that we stored in the database, and we'll verify that in a second. And then here is the token and the expires in that we issued using the utils library that we wrote. All right, so this is what the front end is going to receive as a response, and then they're going to take this token and store it somewhere in local storage so that it can attach it to every single request in the future. Implementing the login post route is a little bit more complicated, but I'll post in the implementation, or paste in, not post, I'm looking at all these post requests. And what we're doing, it's pretty simple, but there's a lot of code here. So we'll start at the top. The first thing that we're doing is we're going to take the username that we received from the login form, whatever the user typed in, and we're going to look in our database for that username. If we then we'll assume that we find the user and we populate it in this user property. We'll say first, if there's no user, so if this user in the database doesn't exist, maybe this person is trying to log in and they haven't even registered, we'll just return a 401 code with a message that says could not find the user. Pretty simple there. This next line, if you watch the Passport local strategy, you'll understand this exactly. But if you didn't, what this is doing is using that valid password function. So up here, the validate password function, and it's basically going to check, okay, is the username that you just gave me and the password you just gave me, are they valid? So it's going to take that plain text password that the user just typed into the login form and validate it with the Node.js crypto library and that function that we already had defined. So this is going to either be true or false based on whether the user logged in successfully. And mind you, this is different from the JWT. Remember, we have not issued the JWT yet. We'll just assume that they're logged out. So if this is valid, we know, okay, this is a valid user. We need to give them a JWT that they can attach to all of their future requests so that they don't have to log in every single time. So here's our issued JWT. It's exactly how we issued it down here. And then we will attach that with the same exact response body that we did earlier. We also probably should just put in the user property here like we did in the register route. And then finally, if the user did not log in successfully, they gave us the wrong password or the wrong username, whatever, then we will return this response where it says you entered the wrong password. And it's just going to be a 401 response because that is like the unauthorized HTTP code. All right, and then we're going to catch any errors, just put it through standard express middleware and catch it in our error handler. I don't even think we have one implemented for this, but that's kind of what that's going to do. All right, so we've got both of our routes implemented, and let's come back to Postman. Just make sure that this is going to work. All right, so we'll go to login, and let's just copy the body that we put for the register because it should be the same. So here's the user that I already have registered in our database. Here's the correct password for that user. Let's make sure that we have the right path here and click send. And we get a success is true, and we get the same exact response. Here is our JWT that we will store in the browser at some point. All right, so we are done with the bulk of our work here. The last thing that we need to do is just test to see if our Passport JWT middleware is working correctly. So far, we haven't even tested the Passport JWT middleware. We've just been doing the basic username and password register and login and issuing the JWT. All right, so coming back to VS Code, the way that we're going to test this is in this first route, which is the protected route. And we are going to pass in the Passport middleware right here. So we'll say passport.authenticate, and then we're going to say that we want the JWT strategy, and we're going to pass in an object that says session false. And the reason that we do that, if you're familiar with the Passport local strategy that we did in previous videos, we were using the Passport session middleware to actually interact with the Express session middleware. But we're not using this here because we're using JWTs, so we say that that's false. All right, so what this is going to do is execute that verify callback, so this function right here, and if we successfully validate the JWT that is attached to the request, it should let us into this route, so we should be able to print something. Let's see if we can get in here. All right, so we'll just say res.status200 .json, success will stay consistent here, is true. Message is going to be you are authorized. We are now ready to test this out. So let's go to Postman, and we'll come over to the protected route. Again, we need to put in that path. And here's where the magic comes in, but also kind of gets really confusing. We have to attach the JWT that this user owns to the authorization header. Now in Postman, you have the option to put it here in the authorization tab. You could just do bearer token and you put the token here, but we're not going to do that. We're just going to stick with basic HTTP headers to keep things simple. So we're going to use the authorization header, and then the value that we will pass in is that token that we received over when we registered or logged in. So we just logged in, so we're going to take this entire token, including the bearer portion, and we're going to copy that into the value right here. So this value, because it's in the authorization header, and because it says bearer with a space and then the token, which is exactly what the Passport JWT middleware is expecting, that middleware is going to take this value, it's going to run it through the verification function using the JSON Web Token library and hopefully authenticate us correctly. So we're just doing a GET request. Let's send it, and it says success true, you are authorized. So in this case, we just copied in the bearer token here, the JWT, in Postman. But obviously, if you're implementing an application, you're going to do this on your front-end client. So for example, Angular. And you're going to want a way to, you'll probably store it in local storage after you've been issued this, and then you will write some sort of logic to attach it to every request. But that's not the purpose of this video. This video is just to show you how to configure the Passport JWT strategy. So if you wanted to watch that, that'll be probably one of the next videos or something like that. But the last thing I wanted to do in this video is just kind of a quick recap to show you exactly how you're going to be using this. All right, so every route that you want to protect using JWT authentication, you're going to use this syntax right here. If you wanted to simplify it even further, you could probably write yourself a middleware that just calls this method, and then you only have to pass in like a couple letters. But if you wanted to, you can pass in this exact syntax every single time. Now, this is very different from the Passport local strategy, because if you remember when we did that, if you watched that video, we only called the Passport.authenticate method one time, and we called it in the login post route. And then after that, what we were doing to check whether this user was authenticated was saying if request.session.passport.user exist, or I think we had a shorthand method, if request.isAuthenticated, that's how we were validating whether a user was logged in. But since JWTs are by default stateless, we're not using sessions. We have to call this every single time so that the Passport middleware can, grab the JWT that's included in the request and verify it. So it's pretty simple actually. This is all you're going to be using. Attach it to every request that you want to authenticate, and you could even come over to your Passport verification and have some sort of different logics. You could say in this part of the body, you could say if user.admin, if you wanted to validate like an admin property or something. You can get pretty creative with it, but that is the basics of using the Passport JWT strategy. I just want to take a few moments to say congratulations if you've made it to this point. The remainder of the video is completely optional for you. You can fully say that you understand the basics of user authentication in Node.js, Express, and Passport.js. If this video has connected the dots for you in one way or another, I'd really appreciate it if you went and checked out my channel. Much smaller channel than the one that I'm on right here, but I make a lot of web dev related videos and post on a weekly basis, at least at this point. So go check it out, subscribe, like a video. That would be extremely helpful to me and I'd really appreciate it. All right, the last part of this video, as I said, is completely optional and we're going to be covering two things. Number one, we're going to be covering how do we actually take Passport.js out of the equation with the JWT strategy. Believe it or not, the Passport JWT strategy is just using the JSON Web Token library under the hood, and we can do the same thing. Well, Passport.js has a lot of strategies that really alleviate a lot of the work that you would have to do, and I'd highly recommend using them. The JWT strategy is a little bit unique in the fact that I don't think that the Passport JWT strategy adds a whole lot of incremental value to you. Now that is, of course, if you understand what you're doing. And since we just talked for many, many hours to learn how all of this works and we actually do know what we're doing, we can implement our own JWT strategy pretty easily. And then in the final part of this video, we're going to walk through the basic implementation of a JWT strategy with Angular on the front end. Now, of course, this will not apply to all people. Not everyone is an Angular developer or has an interest in that, but I did want to tack it on to the end in case you are working within the Angular framework and are confused. How do you take all these concepts and translate it to, the front end and use local storage to keep your users logged in and communicate with the backend that we just wrote? All right, let's go ahead and first jump into how do we write our own custom JWT authentication strategy. So what you see on the screen here is our application. It looks a little bit different, got a slightly different environment as I'm recording this video, which is kind of recorded at a separate time as an addition to this course. So everything is the same though, don't worry about that. Let's go ahead and open up Postman just so that I can prove that out to you. So if we go to the register route, we'll put in another test user and we'll send that request. And it's not going to work because we're not actually running the server at the moment. So let's go ahead and run the server, try that again, and we should get a successful creation of the user. Now let's copy these same credentials. We'll copy the same credentials into the login right here. Click send. And we should get a bearer token. Let's copy that bearer token, go to our protected route, and drop that into the authorization header value. Click send, and it says you are successfully authenticated to the route. So as you can see, it's the same exact thing, nothing has changed. But what I want to do now is close out of here, and I want to create a new branch. So we're going to create a new branch called custom JWT. And what we're going to do on this branch is we're going to completely rip out the Passport.js implementation and add in our custom JWT implementation. You might think that sounds really difficult, but it's actually not. And although there is a really good use case for Passport as a middleware and framework, such as the local strategy and a lot of the delegated authentication, such as the social logins. Truthfully, the Passport JWT strategy does not really do a whole lot of heavy lifting for us. Quite honestly, I prefer to do my own custom implementation when working with JWT. So the most obvious place to start is going to be in the Passport.js file where our implementation sits. Let's take a look at what we might have to change. So the first thing that I see in the options is that we have this method called extract JWT from auth header as bearer token. So we need to be able to take the authorization HTTP header and grab the correct token and parse it in our code. As I mentioned earlier, Passport.js is doing that for us, so we don't have to do it on our own. But as we're ripping Passport out right here, we're going to have to write a custom function to do this. Furthermore, in the main implementation, this is just a middleware. So we're just going to replace that with our own custom middleware function. That's all it really is just a function. And we're basically going to verify the JWT that is passed through the request. and then either authorize or deny access to that given route. And then that's going to play out once we go to the routes over here, where you see in the protected route we're using this Passport.authenticate method. We're just going to replace that with our custom middleware function that we're about to create. So just to start us off, let's go ahead and start removing some things. So let's comment out the passport declaration up here, and let's also remove the authenticate method right here and see how that changes everything for us. So we should still be able to start the application and then go over to Postman, go to the protected route, and we can uncheck this authorization and click send, and it says you are successfully authenticated. Now that's obviously not true, because what we did was just remove the middleware that's authenticating us. So we need to replace this with some other middleware, and we're just going to throw this in the utils file because we've already got this being imported. So let's open up utils, and you can see we have a lot of our helper methods in here, and what we can do is actually create our authentication middleware as well. So let's go ahead and create a new function, and we'll say this function will be called Auth middleware, something like that. And what we need to pass in, as with any middleware, is going to be the request object, the response object, and next. And then of course we're going to create that as a function, so we'll drop it down here. By default, let's go ahead and just send a 401 unauthorized error. So the 401 HTTP status code is for unauthorized, and if we were to, let's save this, go back to our users right here and add back in the passport authenticate method, and then uncomment the passport import, this is going to put us back to where we were. And if we go to this protected route and we've got the authorization removed and click send, we should get this unauthorized response. And if we click through this, let's see, we can look at the headers, and it says the status is 401 unauthorized, and then it explains that error, similar to 403 forbidden, but specifically used for when authentication is possible but has failed or not yet been provided. So that's a good just overview of the 401 error, and we can also see that we're doing this in the res.status right here in the login route. So we're already a little bit familiar with this, but by default we're going to make this auth middleware just send that 401, and maybe we can even stay consistent with our login. So instead of just sending it, we'll say res.status and then give it a payload or a response body. So we'll say res.status is 401, the success is false, and the message is going to say you are not authorized to visit this route. From this point, let's go ahead and copy one of these down and replace our export so that we have the auth middleware export. So that's going to export it from this file, and now we can actually use it over in users.js. So we've got this import already. So let's comment out passport again, just so that we're not importing that anymore, and we can go ahead and delete that because we're not going to toggle that back on yet or anymore. So we'll go to utils.auth middleware, and that's really all you have to pass in. You don't have to pass in any parameters or arguments or anything. So let's go back to Postman and try out our protected route. So let's click send and see what the response is. We get a success false, you're not authorized to visit this route. And the reason we're getting that is because when we run this route, instead of getting what's in the body of the route, we're passing through this auth middleware that we just created, and it's by default giving us an unauthorized status. But that, of course, is not what we are wanting to do here. We're wanting to get the JWT that was passed into the request and then pull out the token from that and validate that token using the JSON Web Token library. Because after all, that's all that Passport JWT is doing in the end. What I have pulled up here is actually the Passport JWT strategy implementation. And you'll see that on the verify JWT, this is all that's happening. You're just using the JSON Web Token library to verify the token itself. So that's not going to be all that difficult for us to do. And then furthermore, we have the extract JWT, which is going to be, if we come back here, go to Passport and see this method right here. So the from auth header as bearer token. So if we were to go to that same repository, we can go to the auth header, or no, the auth header.js, which is going to have a parse auth header method, which is going to basically call the extract JWT. And then this has a bunch of different ways that we can do this depending on what our header looks like. But in our case, it's from auth header as bearer token, as we saw right here. And what that's doing is calling another method which has some utility functions, so on and so forth. So that's not all that difficult to implement either. Let's go ahead and see what that request header looks like. So if we were to drop into the auth middleware in console.log the request, and then I believe we can just say the request.header, if I'm remembering this correctly. And then we came over to Postman, and we went to the headers, turned back the authorization header, and click send. And then we'll see something printed here. So maybe I did not print this correctly. So I'm printing a function, not the actual header. So I think I have to say request.headers maybe instead. So let's go back, send this request again, and now we're getting something a little bit better. So we're seeing our header printed out. Now let's go back to Postman, and instead of this authorization header, let's go ahead and copy the token itself and turn this one off, and then go to authorization and click bearer auth. So if we copy in this token and click send, we should still get the same header. So we're always going to get this authorization property, and that's kind of what it means when we're looking at the Passport implementation and it says that we need to extract JWT from the auth header as bearer token. That is us telling the Passport library, hey, we expect this certain format, so parse it accordingly. So that's basically what we're saying, is we always expect this exact format to be passed in. And in our utility method, we're going to have to take that into account. So the next question is, how do we actually parse through this token? Well, we can actually split the token because, as you see in the format down here, there is no spaces other than between the bearer and the token itself. So if we have a valid bearer token, we can just split it with a JavaScript method. So let's go ahead and make a variable called token parts. And then what we're going to do is we're going to say request.headers.split, and we're going to split it by a single space. Now if we console.log the token parts instead of just the entire header, you're going to see something that we can work with a little bit easier. So let's go ahead and remove this. We'll go back to no auth because I think it's a little bit more straightforward when we're just passing in the authorization header. And let's go ahead and click send. And it looks like we got some issues here. It says request.headers.split is not a function. And that is, of course, because I'm not thinking at all, trying to talk and teach and code all at the same time. It's a little bit difficult sometimes. I don't want to split the headers. I want to split the headers.authorization property. Let's try that. That might work a little bit better. And this time we should get an array. So our array has the bearer and the token keywords. And then from here, we basically need to check to make sure that this is the correct format. Because what if we get something that's incorrectly formatted passed as an authorization key? That would obviously be invalid. So what we're going to do here is we're going to say if the token parts 0 is equal to the word bearer, which is what we would expect, and the token parts number 1, so the first index, which would be the actual token, if that matches a certain regular expression, then it's going to be valid. And that regular expression, as we learned with the JWT portion of this course, is always going to be a series of characters with a period, and then another series of characters with another period somewhere here, if I can track it down and find it. So right here is the second period, and then some more characters to follow. So the way that we can validate that is with a regular expression that basically just looks like characters, period, more characters. If it doesn't follow that format, then it's invalid. We don't want to let the user into the route. So we can actually use the string matching function, and we can pass in a regular expression that I've already written. So this course is not about regular expressions, so you're just going to have to take my word on this. This right here is going to basically say, look at the string that we've got down here and ask, whether it fits that format of characters, dot, characters, dot, characters. And if it is, then it's not going to equal a value of null. So if it does match, then it's going to give you a results array. If it does not match, it will return null. So if we check and make sure that that does not return null, then we know that we have a valid JWT format. So we're basically saying if we make it into the body of this if statement, then our token is valid. We are now ready to actually write the verification portion of this with the JSON Web Token library. Now, we've only imported our private key up here, but we also need to import the public key in order to validate this. So remember, we sign it with the private key and we verify it with the public key. So that's the order we're going in. So let's go ahead and copy this down, and we're going to grab, instead of the private key, we're going to grab the public key. And then we're going to change the variable name, copy this down, change private key to public key, and update the variable here. Let's make sure that we're getting that correctly first. So if we get here and we have a valid token, which we should be able to console.log the public key constant variable. So we restarted. Let's try to visit the protected route, and you can see that we're getting that public key printed out just fine. So that's working. Now we just have to implement the JSON Web Token verify method that it comes pre-built with. So if you were to go to the JSON Web Token documentation on NPM and search for the JWT.verify method, you can see that it takes in a token, which is going to be the JWT, a secret or public key, so that will be our public key, and then of course we have some options and a optional callback function. You can read through this, but I'm going to go back and just implement it and show you exactly how to use it. So we've got the imported JSON Web Token library, and all we need to do is come down in here and say, let's say verification variable equals JSON Web Token dot verify. Now it's going to ask us for a token, which we're going to give it the token parts at index 1, which is the actual token. We're then going to pass in the public key, and then in the options, it asks us whether we want to supply an algorithm. So if I were to go back to this documentation, we have in the options in algorithms, which is a list of strings with the names of the allowed algorithms. For example, HS256, blah, blah, blah. So all we have to do is pass in the algorithms, and then in the array, we need to pass in RS256. And you might ask, how did I decide on that algorithm? Well, if you remember from the Passport.js file, where we were giving the options to the Passport middleware, we were basically saying, I want to extract it as a bearer token, which we did here in these lines right here. Then what we said is I want it to be using the public key. So we passed in the actual public key, just as we did right here. And then finally, we said that we wanted the RS-256 algorithm, which is basically the public-private key pair or asymmetric cryptography. So that's what we're doing here in the algorithm section. So we're basically giving it the same options, we're just doing it more directly. So let's go ahead and console.log the verification and see what we're getting. So let's go back to our Postman, if I can get there, and click send. So we sent the request, we'll come back here, and we're getting this value right here, which is going to basically be an invalid value if it was not successful, or we'll get this object if it was successful. So let's go ahead and manually put in the wrong key to see what happens if it's not. So we'll just remove this first E at the beginning of the bearer token and click send. And now we're going to go back to our library here, and it's going to say JSON Web Token error invalid token. As you can see here, this has thrown us an error, and we don't want that in our application. We want to handle all of our errors. And if we were to go back to our documentation here for this method, it's going to give us an asynchronous way to do it and a synchronous way to do it. Let me just get rid of this search so that we don't see that. And for the synchronous method, it says if a callback is not supplied, function acts synchronously, returns the payload decoded if the signature is valid, and optional expiration, audience, or issuer are valid. If not, it will throw the error. So that's basically telling us that we need to handle an error if we're doing it synchronously, which is how I want to do it here, just to stay simple. So we can use the built-in try catch block. So we'll say try catch and then pass in the error. And if we go ahead and run this method right here, if I can copy it correctly, if we run that right there, it should pass. And if it does not pass, it will throw an error. And at that point, we can console.log the error just to see what we're dealing with. So let's go ahead and see if we can verify it. So basically, if we don't make it to the error state, then we know it was successful. So we've reconnected. Let's send the request with an invalid request. And you'll see that we have printed out the error now. So it looks like it threw the error, but we're actually just printing it and handling it gracefully. So based on this, all we need to do now, we've just kind of tested everything out. Let's get rid of this console log statement. Let's also not print a variable that we don't have anymore. That's a problem. And then we'll come down into the catch block, and if we have an error, that's where we're going to put this status of 401. So as of right now, if it was successful, it's not going to do anything. It's not going to return anything. If it's unsuccessful, we're going to get this message right here. So if we go back to Postman, we should expect to get the "you are not authorized to visit this route" message, which is what just happened. So that's working great. And now what we need to do, let's go ahead and assign this to a verification variable once again. And now what we're going to do is pass the next callback in here. So we'll just say next, and that's going to pass us through to the next route. At this point, what we could do is we've got this verification stored, and let's go ahead and console.log it one more time just to see what we're dealing with. And at this point, I need to add back in that E character that I had just manually removed from this token. So now it should be valid, and when we send the request, we're not going to get any response yet because we haven't done anything here. But in the terminal, if we scroll to the bottom, we should get this little block of code, which is some useful expiration date of the JWT token, which we can then use on the front end to, set expires headers or expires in local storage and stuff. So it would be helpful to pass this along. So all I'm going to do is say on the request object, I'm going to assign the JWT equal to the verification. And then I'm going to say next to pass it to the next middleware in the chain. So at this point, we're passing it to the next middleware in the chain, and now we have this JWT property. So we're going to drop into this route, and now we should be able to console.log the request.jwt. And if we console.log that successfully, then we know that it was a successful verification, and we should see the same object being printed, despite the fact that we're not printing it in our middleware anymore. Let's go back to Postman, click send, and it says you're successfully authenticated, which is good news. And you'll also see this JWT that we had attached to the request object. So believe it or not, we are done ripping out Passport.js and implementing our own strategy. So if we were to come to the Passport.js file and just click delete on this whole thing, we should still be able to run our app. So let's start it. It's going to crash because we're currently importing that into app.js. So if you remember, we're configuring Passport right here. And do we do anything else? Yeah, we're importing Passport up at the top. Just want to make sure we're not using it anywhere else. Let's save that and see what else. Looks like I missed one. So on line 22, here's the initialization call. We'll delete that out, click save. And it looks like we are compiling correctly now. We've deleted Passport entirely. I don't think that we have any other references to Passport. Let's go ahead and check. So that's just in the package, JSON, and then the README. So we're looking good. We have no more references to the Passport library in our code. And now we should be able to go through the entire flow that we went through previously with our custom strategy. So let's go ahead and try it. We'll start with the register route. We'll put in a new user, click send. We've created the new user. We will update our login route to log in our new user. We'll click send there. We've just been issued a new bearer token. And then we'll come to the protected route, copy in the bearer token, and click send, and it says you're successfully authenticated. If we delete some stuff here and pass in an invalid bearer token and click send, it's sending the request and not returning anything for some reason. And I've actually got an error in my code that I forgot to account for because it's not returning a request. So the reason that's happening is because, remember, we're verifying whether this is a valid token in the first place. And only if it's a valid token are we trying the verification. So we need to provide an else statement to catch any time where the actual syntax of the bearer token is wrong, and we'll return the same unauthorized status if that's the case. So now if we come back and click send, we should get an unauthorized response. So I'm glad I caught that. But basically that's just a demonstration of how we implement our own custom JWT strategy, and it's what I use in a lot of my apps for when I'm just getting started and providing a basic authentication strategy. Once again, you can check out the GitHub repository associated with this course and go to the custom-JWT branch to see the code that I just worked on. And last but not least, let's go through how do we implement this JWT strategy on the front end and sync it up with all of the code that we've written on the back end in Express. Today, we're going to be talking about how do we take the Passport JWT strategy that we implemented in our Express application and kind of port that into a front end that will handle the JWT and attach it to each of our HTTP requests. So we're going to do this with Angular, and the reason being is because I, for one, know Angular better than most of the front-end frameworks, and number two, it is very compatible with JWTs. Now, if you were to, let's say, make an Express app and you used EJS as a templating language, and that's how you built your front end. Now, in that case, sure, you could, somehow implement a JWT front end, but it's going to be a little bit more difficult because the pages that we would be loading on the front end are going to be coming straight from the server, well as in an Angular application, it's an SPA or single page application, which means everything happens in the browser. So that includes the JWT stuff, and so it's just very compatible for what we're doing here. Like I said in previous videos, the goal of this one is not to teach you how to write an Angular app. So I'm assuming that you already know kind of the basics of Angular. We're not going to do anything too crazy, but I'm not going to be walking you through the structure of how Angular works and all that good stuff. The goal here is to show you exactly how we take our Express server that is issuing us JWTs and translate that into the front end. So to do that, I want to first walk you through what I've already provided you with. In the previous video, I introduced the GitHub repository. It'll also be in the description here. And when you download the repository, on the master branch, you're going to have a blank template. We implemented the first part of that template in the Express application in the last video. And then the second part of the template is what we're going to be doing in this video. And that is sitting in the Angular directory. And if we open up the main part of this application, you'll see several folders already built for you, and they're all connected up, so this app kind of runs already even though we haven't implemented the actual methods. So I'll walk you through it real quick. Let's start in app.module. Let's see what we've got here. So I've already set up the routes for us. So if we visit login, register, and protected, it's going to load the login, register, and protected components. So that's already set up for us in Angular, kind of gets that out of the way. We are declaring those components here. Let's see, here's the router module, and this is important. We have to implement the use hash option because we have our API from the Express application, and then we have the routes from the Angular application, and we don't want those to conflict. Now, down here, I kind of debated whether I was going to put this in here, but this is the setup for our HTTP interceptors, and that is something that we're going to actually implement, but I've left the structure of it intact, and it's already included in the main module, so you don't have to worry about doing that. But this right here is a very special syntax. You're probably not used to seeing it if you don't work in Angular a lot. So that's the app module, which is the base of the application. App component just has 3 links so that you can load each of the routes, and then I actually put the routes below. So we're pretty much staying on one page the whole time and just toggling between the routes by clicking these buttons up here. I can go ahead and run this just so we can see what that looks like. I don't think we should get any errors. So it loaded successfully. Let's visit in the browser. And you can see that our application is very far from beautiful. The goal here is not to style it up or anything. We just want the functionality. So as I said, if you click each of these routes, they're going to display below. So right now we're at the home route, so nothing is being displayed. But if we click login, you'll see a little ugly login form. If we click register, you'll get the register form, and then the protected route is just going to give us a message. And in this case, we don't get a message because we're not authenticated. So that's kind of the entirety of this application. Obviously, it's not something that you would show to any user, but it does give you the setup and the logic behind how you would start an application. Okay, so let's come back to the code, walk through a couple more things that we've got set up, and I'll kind of show you what we're going to be doing in this video. So the first thing we've got is the Auth service. This is a service that we're going to be spending a good amount of time in. As you can see, we've got 5 different methods that we need to implement in order to kind of manage that JWT that was issued from the Express server. Next up, we have an auth interceptor, which we have to implement the intercept method for this. What this is going to do basically is take each HTTP request and it's going to attach the JWT to it. So this is kind of the magic behind the scenes. Then of course we have each of our components, so the login, protected, and register components. Let's see what I have implemented here. We basically just have the form functionality implemented, so we don't have to walk through that logic. So you see here we have a register form. Then when we submit the register form, it's going to call this method, which sits right here. And in this onRegisterSubmit, we're just going to take the username and password. We're going to make a post request to our Express application, which is on localhost 3000. And then we're going to get a response, and if it's successful, then we're going to navigate back to the login. So don't worry too much about what's going on here. This is basically just making the request to get the JWT from the Express server. And then same with the login. You're going to see something very similar. You have a form here, you have a method on submit, and that method is going to make a post request to the login route of the Express application. So go ahead, I know I didn't cover absolutely everything, so go ahead on your own time and just pause the video and take a look through this Angular app. Just get familiar enough with it, and then we will get into actually implementing the JWT strategy here. I think the first thing that we should do is implement this service called Auth service. Now this is going to manage how we store and retrieve the JWT token or JWT that we have been issued from the Express server. Before we do that though, let's go and quickly review what we're getting from the Express server. So if you remember from the last video, when we register a new user, let me go ahead and register a new user real quick. We send that. Oh, and it's not going to work because the Express app is not running yet. So we need to first run the Express app. Okay, Express app is running. We can go back and actually, how do we cancel this request? Cancel. All right, so let's send it one more time. This time we should get success true, and here is our JWT. So this is how we're getting information from the Express server, and then if I wanted to log in with that same exact user, I could do that with the login route, and it's going to give me the same exact data. So this is the data that the Angular application expects, and once we get that data, we're going to basically take this token and put it into local storage. So that is what this auth service is doing. It's basically saying, okay, once we get the response, we want to set local storage, then the logout method will basically delete stuff from local storage, so on and so forth. To help us out and kind of keep things straight in our heads, I'm going to copy in this response that we get from the Express application when we register or log in a user. So I'm going to put this here and just comment it out so that we have a representation of what we are expecting to receive. And this, when we implement this first method here, the response object should be this right here. So the first thing that we need to do in the set local storage, this is going to be when we receive our JWT and we need to put it in local storage. So the first thing that we need to do is actually figure out when this JWT expires. So in the response body up here, we're going to get a value of 1 day. To make things a little bit easier and not have to deal with JavaScript dates and stuff, we're going to use a library called Moment.js, which is, here's the documentation for that. and it's pretty simple, to be honest. Moment is the main function, gives you the current moment, and then you can do whatever you want with it. You can format it. Here's like the live, on the right side here is like the live updates to these pieces of code. You can also do things like add certain amount of days. So this is what we're going to be doing. We're just going to be doing moment.add and then pass in that 1D, which represents 1 day. So if we come back to the Angular application, we're going to just store, let's say, expires equals moment dot add, and then we're going to say the response object dot expires in. All right, so we've got the response object right here, and then the expires in property. So basically this right here equals 1D, and if we add that to the current moment, that's going to give us the time that this JWT expires. After we've figured out when this JWT expires, we need to set two things into local storage. To do that, we can just say local storage dot set item. And this set item method is going to take two values. So first is the name of, or first is the key, and second is the value. So we'll say token is the key, and then the value of that, if we look up in the object that we should be getting here, it's going to be dot token. So we will say response object dot token. And if you remember, that token has the bearer included, so just keep that in mind as we go forward. Local storage dot set item and expires. So that's going to be our second one. And that is going to be on the response object as well. But we actually have to do a few things to this, or excuse me, this is not on the response object, it is what we just set right here. So we need to pass in expires, and then we need to do a few things to it. So first, we need to get the value of this. So this is just a JavaScript method that's going to take the primitive value of a string object, and then we will say JSON.stringify and pass in that value. So nothing too special going on here. It's literally just to get us in the correct format. And that's pretty much it for the set local storage method. So we'll receive this object when we log in or register, and then Angular is going to take that object, pass it into set local storage. We'll see where this is actually used a little bit later, but it's going to take that response object and set these two items in local storage. Now to log out, we're just going to remove those two items. So we can say local storage.remove item, and we just pass in the name of the item that we want to remove. So once we remove these items from local storage, when Angular checks to see whether they exist, it won't find them, and it will make the user log in again. So that's kind of what is going on here. The next thing that we're going to do is this getExpiration method. And that is because this method is going to be required to see if a user is logged in. Now, if we issue a JWT to a user, then that means that the Express application has already done all of the cryptographic logic to decide whether the user is actually valid. So if the Angular application receives this response, then we know that they are pretty much logged in. So all we have to do is check whether the JWT is expired, and if it is expired, we need to delete it from local storage. Otherwise, we can consider this user to be logged in. So to grab that expires from the local storage, we're just going to paste in a few lines here. So first we're going to get the item. It's not expires at, it should be expires as we set it up here. And then we're going to figure out So JSON parse is going to take the JSON object and make it a JavaScript object. This last return value is just going to calculate using the moment library. It's going to just calculate the point in time which this JWT actually expires. And then we'll come up in the isLoggedIn route, or not route, but function, and we're going to take this value, the expiration value, and see if the current time is before or after it. To do that, we just say return moment.isBefore. This is just a method that we have available to us, and then we're going to pass in this.getExpiration, which will return us the moment that this JWT expires. And if it returns true, then that means that the JWT is still valid and we should still be logged in. Then the last method here is just going to return the opposite of this.isLoggedIn. Pretty simple. Now that we've implemented this auth service, let's go ahead and see it in action. Before we do that, I want to remind you what is happening when we register a user using the register component. When the user presses submit on the register form, this post request is going to be sent out to our Express application, which is running over here, which will return that big object that we were talking about and looked at. And then once we receive that response object, we're going to pass it into the set local storage method, which will set our token and expires properties in local storage. Let's test this out. Go to Google Chrome. Right now, if I refresh the page, you'll see that in the application, we don't have anything in local storage for this application. Now let's go to the register route and let's put in something like JWT test and then a password of 123. And when we click register, we should be redirected to the login route, and you'll see that these two, the token and the expires, has been set to the local storage. We also will console log the user object that we got back from the Express server just to see that it was successful. At this point, we actually don't even need to log in necessarily because we've got these things set in the local storage. But why don't we just go and do it, JWT test 123, and then we're going to be redirected to the protected route. But it says you are not authorized to visit this route, no data is displayed. And the reason being is because we have not yet implemented our interceptor, which is going to take the JWT that is sitting right here in local storage and append it to every HTTP request that we make in our our Angular application. In other words, we need to find a way to, when we click visit protected route, while there is a token that is valid in local storage, to get it to actually work. Looking at the protected component, you can see that what this is doing when we click visit that route, so ng on init, so when this component is loaded, the first thing that it will do is make a GET request to this link right here, which on our Express application, as you saw in the last video, is only going to allow users to receive the correct data if they are authenticated with a JWT that the Express server deems as valid. Right here is the protected route, and if we are not authenticating correctly, if we don't have a JWT attached to this GET request, or the JWT is invalid, we should receive a 401 unauthorized error. If we are valid, then we should receive this message right here. So here's the message, you are authorized. Okay, so let's close this out, go back to the protected component, and you'll see that if we get a response, we're going to print the message attached to that response. So we should see what we were just looking at in the Express application if it was successful. But if we have an error, which is going to be a status of 401 or unauthorized. The message is going to be you are not authorized to visit this route, and we saw that earlier in the browser. So let's go solve the last piece of the puzzle. Open up the auth interceptor, which right now is empty. I'm going to paste in the implementation here, and then we're going to walk through it. So let me indent this correctly. Okay, so again, this is not an Angular tutorial. You're going to have to read up on interceptors, which you can find on their documentation. It gives you a lot of examples. But basically what this is doing is kind of intercepting every HTTP request that Angular is sending out, and it's going to attach, or it's going to run the intercept method. So what we're doing here is first we're grabbing, this should not be ID token, it should be just token. We're grabbing the token from local storage. And then if there is an ID token, so if we get a token from local storage, then so far we're good. What we're going to do is clone the request. So we're taking the current request that is going through the chain of interceptors. It's kind of like middleware in Express almost. And we're going to take that and clone it, but this time we're going to set the authorization header equal to the ID token. So that should set authorization header equal to bearer, and then a space, and then the JWT. Then we say return next.handle and pass in that cloned object. So that should basically, right here, that should successfully attach the JWT. If we don't find a token, which is very possible if the user is not logged in, then we just return next.handle the request, and there's going to be no authorization header whatsoever. We now have an auth interceptor which should attach this JWT token to our request. Now if we go to the browser, to our application, technically if we visit this protected route right now, it should say that we are authorized, because you remember we already logged in, and you'll see that we have the token and the expires already in the browser. So as long as we attach this to our next request, it should authenticate us. So let's try that. If you remember from the last request, there was no authorization header, but now if we visit the protected route, it says you are authorized, and if we go to the network tab, this is a little bit tricky. You're probably tempted to click on localhost, but we need to click on protected, and you'll see that down in the request headers there is this authorization header which has the JWT that we had stored in local storage. So that is the basic flow, and you can use this concept to basically manage your users within an Angular application. And obviously there could be users with different types of permissions, and that would require you to come back to your interceptor and write in some custom logic to say, okay, hey, based on what role this user has, are we going to attach, the JWT or not? And also you might have routes on the Express application that may or may not require authentication. But hopefully this implementation, so the combination of this auth interceptor and the auth service, hopefully those two things, along with the previous video where we talked about how do we actually issue that JWT, have brought your understanding of user authentication to a conclusion, and hopefully this all makes sense. This is just one way that we can implement user authentication in our front end or Angular app. You're going to see a lot of different implementations across a lot of different coding languages. The most important thing is to understand how everything works, how does a JWT work, and how are we supposed to kind of pass it from the front end to the back end. Once you understand that, it should be a breeze to implement your own authentication strategy. You never thought that we'd make it to this point, but we're here. We're at the end of this super long user authentication crash course, and I want to say a big thank you if you watched all the way through. That's really an accomplishment to get through, however many hours this took us to understand all of these concepts. And if you are one of those crazy people that went from the very beginning of this course all the way to the end here and didn't skip anything, I'd love to hear from you. I'm on Twitter at ZG_dev, and I'd really love to hear from you. So reach out, tell me what you thought about this course, or just say hi. Once again, I'd really appreciate if you checked out my much smaller YouTube channel and just gave it a look. And until next time, I will see you later.